Hey, good morning, Tom.
Good morning, you. How are you doing?
Very good. I'm actually in Cannes, France.
Oh, wow.
For now.
Wow. You've been traveling.
Yeah.
So I wanted to get on early just to make sure that audio and everything works. So
Yeah. Thank you so much for that.
but I'm not on until 7, for about an hour now, right?
Yeah.
Okay.
Morning, Alex.
Hi, you. How are you?
Very good. Thank you for waking up early.
How's it going on? How many attendees are expected today?
I assume many of them will be watching our streaming on
I see.
either
You have
YouTube
a live
or
streaming
Bilibili.
now.
Yeah.
Oh, fantastic. Yeah.
And we will record that so people can watch our session on demand later afterwards.
Oh, good.
Thank you for waking up early.
How many attendees are there?
Sorry, we will let's wait for Lee to log online so we can start. He is supposed to be the first speaker.
So how the COVID-19 situation is going on? Yeah.
Well, I'm currently in France. So the probability of getting infected here is very high.
Yeah.
We attended a meeting last week, and there were 6 people, including me, representing IEEE at the conference here, and 2 of us just got tested positive. So,
wow.
Are you one of them?
No, I'm not. Fortunately, I'm not.
Okay, glad to hear that.
Well, let me say if Lee has any technical issue for logging on. Ralph, you probably also need to, well, for our audience, apologize, we probably will start in like a couple of minutes. We have some technical issue to solve. So Ralph,
I'm working on it.
Okay, okay. Meanwhile, let me give you and also our audience some brief background. So this is first session of the Inaugural World Digital Transformation Conference, which is supposed to be, according to our current planning, a series of pre-sessions and hybrid week, hopefully in Shenzhen, China. So we are starting this series of pre-sessions today, and later we will have other sessions addressing different aspects of digital transformation and different hot topics of digital transformation, such as metaverse, ESG standards, of course, and a few others. And we are also open for partners to organize such kind of sessions under the umbrella of this so-called World Digital Transformation Conference. That's our plan to provide a global platform for the digital transformation related experts to exchange ideas, expertise, knowledges, and practices. So the format for today is relatively simple. We have the Zoom participation, and we have live stream on YouTube and Bilibili, which is a major platform in China. And the entire session will be recorded and available for on-demand playback afterwards. For future sessions, we may have some, the format probably would be more fancy. We are still working on trying to host some of those sessions in the environment of metaverse style platform. So we will keep you posted. So the conference main website is, as many of you have already know, is the wdtc.site, SITE. So we will be posting our future plans on that website, and especially in terms of the other sessions, webinars, and also finally, hopefully a hybrid session or hybrid event for 3 or 5 days in Shenzhen or Hong Kong. We're still working on that. Stay tuned, you will be posted. So probably I would suggest we, let me see, I would suggest we change the agenda order a little bit, so that while our Lee is our first speaker, but he is facing some login problems. So probably I should change the order a little bit. So maybe like Tom, would you like to take the first place for?
Sure, I can do that. Hold on a minute here.
Okay.
Let me just.
Go
ahead.
Let me introduce you while you are preparing. Tom is well, his brief bio is relatively low profile. Tom is an experienced owner with demonstrated history of working in the digital storage industry, skilled in hard disk drives, solid state drives, and so on. And he has strong technical development expertise with a PhD focused in electric and electronics engineering. But in addition, Tom is an IEEE fellow. He used to be the IEEE USA president and the IEEE board of directors on the IEEE board of directors. And this year, he is a candidate for the IEEE president-elect in the IEEE annual election. So it's our great honor to have Tom Coughlin, Dr. Coughlin, to be our speaker. So Tom, please.
Great. Would you allow me to share?
Yeah, I think you can simply request.
It says host disabled participant screen sharing. So I think you need to get to let me share the screen.
I guess, Ralph, I think you need to, you need to make Tom the presenter. Ralph, could you do that? Tom, did you see share screen button at the bottom of your Zoom?
Yeah, when I press that, it says host disabled participant screen sharing.
Okay. Well, Ralph, could you hear us? Give me 1 second.
Sure.
Well, you know, it's always
Okay.
Technology is always like this. Okay. Make Tom the
Hey, Tom.
presenter.
Can you try
Oh,
that
there it
again?
goes. Looks like it works. Okay, let's see. Can you see it?
Yes. Yes. Perfect. Go ahead.
Great. Okay. So, hi, I'm Tom Coughlin, and I'm going to talk to you about changes in digital memory ecosystem that are going to enable the next generation of big data applications like artificial intelligence in data centers, at the network edge, and also in endpoint devices. Now, this presentation uses a lot of material from a report on emerging memories. It's written by me and my colleague, Jim Handy, and I'll talk a little bit about that report at the very end. So here's an outline of what we're going to talk about. We're going to talk about why things are changing, why emerging memories are important, changes in the computing model that's making possible or enabling. We'll talk a bit about these particular memories, talk about who's making these memories, some real life applications that are out there today, and finally an outlook on what's going on in this market long-term, summary, and then some references. So let's talk about first why we need emerging memories. So something really interesting is happening in this whole memory market. Although there have always been numerous alternatives to today's leading memory technologies, metaphorically waiting outside, trying to get in. They have never had the opportunity that's recently been developing. Until now, these memories, 4 of which we're going to examine today, have been waiting, again, metaphorically at the door, while the market's dominant technologies, DRAM, NAND flash, static random access memory, and NOR flash, have kept them out through their lower prices. Let's look at why things are changing today and why the market has changed in a way that will provide opportunities for new technologies to replace their entrenched competition. Data growth is exploding. For instance, IDC projects that 175 zettabytes of data will be generated annually by 2025. That's up from an estimated 59 zettabytes generated in 2020. Most of this data is supposed to come from IoT devices, and it has the most value when it's processed real time. Think of, say, driving assistance capabilities. And this will increase the need to store and process data in a device or at the network edge to do that fast processing. And probably only a few % of this data will be stored long term. Greater use of artificial intelligence in devices at the network edge and in data centers is also increasing memory requirements. In addition to the growth of data being processed, the power consumption as well as latency and data rates are important considerations in future system design. This leads us to look at the memory technologies which will enable handling this data tsunami. Memory is a big part of server costs, and it must be efficiently utilized to provide the best total cost of ownership. See the figure to the left's example of this. CPUs, memory, and storage have different life cycles and should be replaced separately. This has driven the development and use of pools of similar resources so they can be managed separately. That includes, for instance, memory pools, now using CXL with DRAM, and possibly emerging non-volatile memories as well. In addition, data access and on-chip data movement are extremely costly in terms of energy consumption. Take a look at the figure on the right, you can see that. This is causing systems and data center designers to rethink architectures in order to emphasize data locality and to minimize the movement of data. The semiconductor industry is being forced to change which memory technologies are used in embedded applications like microprocessors, ASICs, and other system on chips. And that's because flash memory, particularly the NOR flash that's used for code storage, can't scale to keep pace with CMOS logic process advances. This scaling limit was a problem with NAND flash. Planar NAND flash stopped scaling at about 15 nanometers. The industry moved then to adopt 3D structures to continue to provide Moore's law type cost reductions. System on chips use NOR flash, and again, NOR flash stopped scaling at about 28 nanometers with the adoption of the FinFET. Some sort of new memory technology is needed to support these chips' code storage requirements. And that's suddenly providing an opportunity for some other technology to replace NOR flash for all processes below 28 nanometers. But it's not just NOR that's heading for a replacement. System on chips using SRAM to store temporary data. And this SRAM is poised to stop scaling, or at least slow dramatically about 14 nanometers. There will be side benefits of these changes. Alternative memories not only scale past the limits of these established technologies, making them cheaper to produce, but they are also persistent and have more balanced read and write speeds, for instance, than flash. This will impact the way systems and software are configured. Now, we're going to discuss these changes later on in this presentation. So this is a chart that Jim and I used to illustrate the issue of scaling. It shows two lines that represent NOR flash and some new emerging memory technology. Process shrinks have been able to reduce costs for the entire history of the semiconductor market. The process nodes run along the bottom, along the horizontal axis, shrinking as we move from the left to the right. Relative cost on the vertical axis has always declined in proportion to each process shrink. But flash memory has a problem, the NOR flash, after the 28 nanometer node. NOR flash, again, is a non-volatile memory the industry uses to store code in microprocessors, ASICs, and other SoCs, and it stops scaling about 28 nanometers. That causes cost declines to cease. So we see that suddenly that line goes straight. The red line goes straight, horizontal. Manufacturers are addressing this issue by migrating to new memory technologies. These allow further cost reductions and follow the scaling law. These emerging memory technologies are represented by the black line on this chart. Although today they are more costly than NOR flash, their cost will eventually fall below that of flash as general process technologies go below 28 nanometers. SRAM, static random access, has a similar problem. Its scaling slows or stops around 14 nanometers. This is a similar chart that plots the cell area for SRAM designs presented at an IEEE conference over the past few years. The cell area on the vertical axis, which is proportional to cost, is on the vertical axis, and the geometry, again, in terms of lithographic size, runs from left to right on the horizontal axis. The cell area has been shrinking to keep pace with the process, but it abruptly stopped shrinking at about 14 nanometers, it appears. In addition, SRAM is much larger than the persistent memory candidates. This leveling off makes SRAM a reasonable candidate to be replaced by some alternative memory technology. The emerging memory will increase the wafer cost over that of a standard CMOS logic wafer, but the die size for some chips will be smaller thanks to the fact that the emerging memory technology will consume a smaller area than the SRAM memory would. This will reduce the cost of these chips, making the design based on these emerging memories more economical than its SRAM-based counterpart. That's going to drive future chips to migrate to an emerging memory as an alternative to SRAM, which is particularly important big data applications where there's a lot of memory, fast memory required on the chip. Now, DRAM is the working memory used in almost all electronic devices, from consumer to industrial applications and also enterprise. Like many semiconductor technologies, it has become more difficult to continue the pace of lithographic shrinks and increasing transistor density than it was in past decades. This figure shows the slowing of DRAM scaling since about 2007. Although there are variations in supply and demand that also impact the cost and price of DRAM price scaling in dollars per gigabyte declined by about 37% annually for about 37 years, until slowing to about 8% annually starting in 2008. Microprocessors of various sorts are used in applications, again, from data centers all the way to wearable devices. Memory, for instance, NOR flash and SRAM, can be a considerable part of the total die space of a microprocessor. If the memory doesn't scale with the lithography on the rest of the chip, it could take even more space and thus be even more expensive. This is, again, driving demand for these emerging memories that can continue to scale and allow you to have a fair amount of memory on the chip, without the chip growing in size. Now, the acceptance of an emerging memory technology depends upon its pricing. This is an important point. To capture a mainstream market, a memory must be cost competitive against established technologies. This cost structure can only be achieved through high volume manufacturing and shipments. Products that don't reach this volume must play in niches because of their higher prices. A good example of that is the 3D crosspoint memory that Intel and Micron developed, in which Intel calls Optane. This chart represents computing's memory to storage hierarchy in a sense. For a memory or storage technology to make sense in this hierarchy, in this log-log scale, it must be cheaper than the next fastest technology on the horizontal scale and faster than the next cheapest technology on the vertical axis. To get that 3D crosspoint adopted into this memory hierarchy, Intel had to overcome a chicken and the egg problem. This new memory technology, 3D crosspoint, must be cheaper to sell in volume, but on the other hand, 3D crosspoint must sell in volume to get cheaper. The same problem stands in the way of other emerging persistent memories acceptance. NOR's hard stop at 28 nanometers, however, and SRAM scaling limits open the door for other technologies to displace them for emerging memory and SoCs. Today, MRAM is a leading candidate in this race. We'll talk more about that. So these changes are going to cause computing itself to change. And there's new developments I'm going to talk about that are going on that involve memory and storage that will be part of those changes. All these emerging memory technologies are non-volatile, by the way, and that brings persistence not only closer to the processor, but we believe that it will eventually bring persistence into the processor itself. Even registers may eventually be persistent, but that's not right around the corner. So let's talk about where things are today and in the near future. Today, there's a lot of excitement about using an emerging memory in standard computing systems. Not only is an emerging memory attractive as a new layer in the memory and storage hierarchy, like we showed a few slides back, but it also provides a path to interesting architectural innovations. In particular, innovations that solve data motion issues, which are common in a von Neumann type computer. Lots of energy and time are wasted moving data around. These energy and time issues can be addressed by moving from this von Neumann type architecture, where we have very distinct units that we move data around between, as illustrated on the left, to a memory-centric approach as illustrated on the right, which moves towards less data movement, more processing closer to the data. And this opportunity has led to new protocols like OpenCAPI and CXL. These approaches support memory disaggregation by removing some memory from behind the processor. Memory pooling and sharing to more efficiently use storage and memory to address new problem classes, and heterogeneous computing, which allows data to be processed by a variety of types of accelerators. Note that the memory-centric system includes a DRAM connected directly to the CPU. We'll call that near memory. It has lower latency. And a far memory at the center of the diagram. This is labeled SCM memory. SCM in this case stands for storage class memory, so persistent memory of some sort. Since the far memory is shared, its data path to the CPU must be arbitrated. And that adds a little bit of latency, and thus we use this term near and far memory, and that'll be important for a point I'm going to make in just a minute here. Industry is slowly converging on a preferred mix of these solutions to solve today's and tomorrow's problems. CXL is backed by a big consortium and will be a switched memory channel enabling pools of non-heterogeneous memory with various latencies and data rates in storage boxes. And some of these be persistent, some of them not. CXL supports memory and accelerators for resource pooling and allocation. DDR channels, that near memory, will continue to be used for low latency memory, at least through DDR5. And after that, a parallel data path, there may be some problems in going to higher speeds. What will happen then beyond DDR5? It may be that higher data rates may drive the use of a lower latency serial interface rather than parallel memory interfaces, at least for applications that need that performance. For memory, the industry appears to be moving towards a specific mix, divided by whether the memory is near memory or far memory. CXL is gaining popularity for pooling heterogeneous memory or memory with mixed latencies and data rates, and the memory on accelerator cards within a box. Gen Z, which is now part of CXL, is likely to be used to connect storage boxes and racks together. Now, this near memory that's the far memory approaches there. Near memory has three candidates in the running: the traditional DDR channels, which should continue to be useful for smaller near memory systems, at least through DDR5, and high bandwidth memory, HBM, which provides more bandwidth than DDR, but it's more flexible, less flexible and more costly. For instance, this is used by NVIDIA's GPUs. They have high bandwidth memory. And then another interface called OMI, which is the open memory interface, currently used by IBM's power processors and certain FPGAs. Now let's take a closer look at how these near memory interfaces compare against each other. This chart illustrates the operating spaces of these three near memory interfaces. This is where the fastest data processing is for whatever's being done. The chart here shows DDR4, DDR5, high bandwidth memory, as well as the open memory interface. DDR provides a satisfactory solution for near memory in PCs and smartphones, but it falls short for high-end servers and accelerator cards. Many accelerator cards today, which need higher performance, many accelerator cards today use high bandwidth memory because of its high bandwidth, especially if they can operate in the limited memory space afforded by HBM. It's basically made with stacks of DRAM on top of each other. HBMs are those stacks. They provide 1,000 to 2,000 parallel signal paths. That's where they get the speed from to the processor. This can improve performance, but the processor and the HBM also have to be intimately connected. HBM, the high bandwidth memory, is used in applications that can accept its significantly higher price. Those through wafer visas are expensive in return for its blazing speed. Although HBM is a help, it's considerably more expensive than standard DRAM, and it's only available in stacks of no more than 12 chips, limiting its use to lower capacity memory arrays. Now, this open memory interface, or OMI, uses existing high-speed serial signaling PHYs with a custom protocol to connect the processor to its DIMMs. These differential DIMMs are made of standard low-cost DDR DRAMs and an OMI transceiver chip. OMI can provide near HBM bandwidth at a DDR-like capacity and price. Now, another interesting development is this UCI, Universal Chip Interface, Interconnect Express. It's a new standard for connecting 2D planar, basically, and 2.5D, that is a little bit of chip stacking, chiplets in a system-on-chip package. Uses range from SoCs for handheld devices to high-end servers. This UCIe standard permits mixing and matching dies from multiple sources with different packaging options. UCIe combined with CXL through a UCIe retimer allows extending off package to connect with other media, for instance, optics, electrical, or microwave, that's communication media, in order to access memory, storage, and processing pools. Going to 3D integration, that is where we're really stacking wafers, chips on each other, often called heterogeneous integration, would create stacks of interacting chips, providing even denser compute packages with less data movement and lower latencies. And these are also on the horizon, even going beyond that 2D and 2.5D system on chip packages. So we talked a bit now about what's driving these changes. We talked a bit about the computing architecture changes. Let's take a look at the memories themselves, these non-volatile memories that are going to help remake the ways that we do computing. There are many emerging memory types. They're vying essentially to replace NOR flash at the least. All share the same attributes. They all have a small single element bit cell that promises a scale smaller than current technologies in order to support small, inexpensive die and 3D stacking. They also promise to be easier to use than flash memory by supporting write in place with no need for a block erase, as in flash memory. And they have more symmetrical read and write speeds. Finally, they're all non-volatile or persistent. Data doesn't disappear when power is lost. They can all be used as persistent memory. New memories are necessary for Moore's law scaling to continue. These technologies include ferroelectric RAM, that's random access memory, MRAM, magnetic random access memory, resistive RAM, and phase change memory, like the Intel Optane memory that we discussed earlier. Let's talk about MRAM first. It's shipping today, but in relatively low volumes. Over the history of the technology, Everspin, the company that's shipped the most of these standalone MRAM chips, has shipped over 120 million of these chips. The company has a partnership with Global Foundries. They're building 300 millimeter wafers for Everspin, but they also license the MRAM technology from Everspin, and they're offering it to other customers for embedded memory applications and system on chips. We've listed some high-profile applications for Everspin's MRAM here. Another company, Renesas, is shipping an MRAM chip that it inherited through its acquisition of IDT. Other foundries are now offering an MRAM option to their SoC clients, including Global Foundries, TSMC, Intel, Samsung, as well as others. Phase change memory, 3D crosspoint example of that, is another technology that is shipping in volume. The most widely known example is the 3D XPoint, and sold as Optane SSDs and DIMMs by Intel. It builds on technology that Intel has had in development for over 50 years. Their first Optane SSDs shipped in 2017, and the first DIMMs shipped at the end of the following year. Both are currently used in storage systems and other computing applications. Intel was using Micron Technology as its manufacturing partner for this technology, but Micron decided to exit this business last year and sold the plant that it was using to make 3D XPoint. In addition to this Intel and former Micron effort, ST Microelectronics currently produces phase change memory-based microcontrollers for automotive applications. Resistive RAM is our third technology. It's also in production for discrete devices, but in a very quiet way. It has been shipped by Adesto, now a part of Dialog, since 2013. Dialog plans to license its CB-RAM memory technology to global foundries to be offered as an embedded non-volatile memory option on its 22FDX platform and in future platforms. ARM announced that the spin out of Surfy Labs to develop and license new types of non-volatile memories based upon correlated electron materials, or CE-RAM, in a joint development project with Symmetrix Corporation. Other companies currently ship resistive RAM into both commercial and military and aerospace applications. And leading foundries are supporting resistive RAM as another alternative to embedded NOR flash. In fact, if we look at the list of foundries we talked about earlier, many of them are also offering a resistive RAM option in addition to MRAM. Now, finally, we come to the oldest emerging memory technology, ferroelectric memory, or FRAM. Surprisingly enough, this technology predates the development of the integrated circuit. The photo on this slide was published by Bell Labs in 1955. It shows a single SBT crystal with vertical and horizontal metal traces to connect with it, and it was meant to be used as a non-volatile memory. From the perspective of unit shipments, FRAM has also shipped more than all other emerging memory technologies combined, because it's found its way into over 4 billion chips. It's most commonly used in RFID cards, thanks to its extraordinarily low write energy requirements. When using harvested energy, you want something to be able to write without using a lot of energy. Until recently, FRAMs were based on unfriendly materials such as lead and bismuth that most semiconductor fab manufacturers resisted putting into their factories. But in 2011, NAM Lab in Dresden, Germany, found that a crystalline form of hafnium oxide has strong ferroelectric properties. This created new life for ferroelectric memory, and hafnium oxide is commonly used as a high-K dielectric in leading-edge CMOS processes. Fab managers understand how to make it in high volumes. Besides its use in ferroelectric memories, this type of hafnium oxide is also being investigated for other interesting applications, for instance, put into DRAMs. Researchers have used it to produce a 3D DRAM similar in process to standard 3D NAND flash, for example. So let's look at who's making these emerging memory technologies. So leading foundries, those processes finer than 28 nanometers, now are offering emerging memory technologies to their customers. These foundries include TSMC, Samsung, Global Foundries, Intel, UMC, and probably others as well. They're offering spin tunnel torque MRAM today, but they're planning on offering spin orbit torque, or SOT MRAM, and other MRAM technologies in the future. Those are capable of working faster and also operating at lower energy levels. Although today's products aim to replace embedded NOR flash, newer technologies can compete against SRAM and are already being used to displace some higher level SRAM today, as we'll talk about in just a few minutes here. And other companies, and possibly even DRAM down the road. We'll show how the unit volumes could get to those levels where that might be possible. Other companies offer resistive RAM and also ferroelectric RAM today. Now let's look at some applications that are already using these emerging memory technologies. We're going to start off with IBM's FlashCore module. It was introduced in 2019, and they're the storage modules used in the company's Flash Systems family of products. The FlashCore modules are now available with storage capacities up to 38.4 terabytes. Everspin MRAM chips are used for write caching in these SSDs, journaling, to keep logs, and also for data buffering. The FlashCore modules use QLC flash memory for the mass memory, the mass storage. They're using the MRAM cache to reduce the write wearing on this flash QLC flash memory, which has lower endurance than, say, MLC flash. The products are, or even TLC flash, the products are said to have twice the endurance of standard NVMe SSDs. Over 200,000 of these flash memory modules have been shipped with total storage capacities, this is mostly the flash, of hundreds of petabytes. The latest flash core modules allow some processing in the SSDs, and essentially they're moving into this state of computational storage, which is becoming very popular and may have some interesting implications also for computer architectures. These online processing right now in these devices, including compression and decompression, which can increase the effective storage capacity, is done totally inside the drive itself. Many more computational functions are planned. And also the latest generation, Gen 3 of these flash core modules have RISC-V core built into the processing units that could assist in analytics and machine learning applications. So this is a block diagram of a company called Ambic's 4th generation Apollo system on chip, which serves as both an application processor and a coprocessor for ultra-low power battery operated IoT endpoint devices, for instance, smartwatches. If you look at the lower left corner, you'll see the system memory subsystem, which is made of MRAM and SRAM. The chip pairs a 2 megabyte MRAM with a 1 megabyte SRAM. Another device that ships today with embedded MRAM is made using memory technology by a company, IP, by a company called Newman, which is an MRAM IP house. This chip is used by NASA for remote computing in space. The MRAM is naturally less sensitive to radiation than flash memory or DRAM. Its high endurance and non-volatility as well both help to reduce energy requirements and for extended use in a harsh environment like outer space. Each deep neural network accelerator chip that these are has from 1 to 32 processing engines, 32 to 1024 ALUs to perform efficient processing for matrix multiplication, convolution, etc., in order to be allow these devices to make decisions on things to do in space with a spacecraft. MRAM is also being used in Sony's GPS receiver, which can be found in Huawei's GT2 smartwatch. Built on Samsung's 28 nanometer FD-SOI process, this IoT endpoint includes 8 megabits of embedded MRAM. There are many other emerging memory devices that ship in production today. This includes an MRAM microcontroller from NXP, a phase-change memory-based microcontroller from ST Microelectronics, and an FRAM-based microprocessor from Texas Instruments and also from Fujitsu. With all these devices coming online, what's our outlook for the future of this market? This is one of the key parts of this emerging memory report that my colleague Jim Handy and I do every year. And this data comes from our last report. We're working on the new report now. That report was called Emerging Memories Take Off. It shows that the total emerging memory market we're projecting that, including MRAM and also Optane memory, could exceed $44 billion by 2031. This chart shows how the petabyte shipment growth could drive that number. The figure compares the current and projected capacity shipments for the next 10 years for various emerging non-volatile memory technologies, here exemplified by MRAM and 3D XPoint versus DRAM and NAND flash. Now, the assumptions from this chart are that the 3D XPoint is adopted widely by Intel customers and Xeon servers, that embedded MRAM replaces most system-on-chip NOR and SRAM, and that MRAM has strong appeal for these mini AI applications. Note that MRAM shipment growth in this chart includes both standalone as well as embedded MRAM technologies. So, summary, NOR flash SRAM stopped scaling, DRAM scaling has slowed. It's getting harder to make smaller memories, and that is leading to an opportunity for new non-volatile memories, which could fill that void. Particularly, the big attractive opportunity right now is going below 28 nanometers for code storage on embedded devices. And that's going to lead to new memory-centric compute. These changes are leading to new types of connectivity, new ways of disaggregating, new memory-centric computer architectures that could be used for artificial intelligence and other data-intensive operations. That's going to change the storage and memory hierarchy, the way that we use different sorts of technologies. And there's 4 leading candidates for these emerging non-volatile memories: MRAM, phase-change memory, resistive RAM, and also ferroelectric RAM. And leading foundries are already supporting these new memories. There are initial products are out there today. MRAM, and so we're projecting that MRAM and phase change memory revenues could exceed, again, $44 billion by 2031. Just a little bit about the report. If you're interested, it's now available. This is the latest report we have out. And a lot of this information in this presentation was drawn from this report. It describes the entire emerging memory ecosystem, phase change memory, resistive RAM, magnetic random access memory, and ferroelectric RAM. Talks about the company's markets, support requirements, examines emerging memory consumption, both for embedded and discrete devices. It's 230 pages with 36 tables and 155 figures. If you're interested in this, there's URLs at the bottom of this slide where you can check the report out. There are some references referring to SNIA, CXL, OMI, and also our report, of course. And I want to thank you very much. And if there's time, I'd be glad to take some questions.
Yeah, let's see if we can take some questions from attendees. You could put, I believe attendees could put some questions in the chat window, or we can save that for our panel discussion.
There also apparently is a Q&A window, but I don't see
Yeah,
any questions.
Yes, you're right. There's
but I don't see any questions in there right now.
Okay, so maybe we save that for the panel discussion. Thank you so much, Tom.
Thank you.
And,
take care.
Well, I think it's now my turn. I'm going to talk about the metaverse. So I'll share my screen. Give me 1 second. Okay. Well, we just went back to the agenda, and but looks like we still have a couple of speakers having technical issues with logging in as panelists. Anyhow, so let me talk about the metaverse, which is my favorite topic for now. Brief introducing myself. I'm currently the president-elect of the IEEE, and my other roles includes chair of the IEEE VR and AR Advisory Board, and also the chair of the VR AR Standards Committee, and the secretary of the IEEE Consumer Technology Society Blockchain Standards Committee. With that being said, I just wanted to highlight that I do have a, I would say, long history with the metaverse since many, many years ago. But before I share my opinions, I have to disclaim that the opinions expressed here are just my opinions, and not necessarily the opinions of IEEE or IEEE. So first of all, what is the metaverse? We have a brief history. Many of you have already know that this keyword, the metaverse, started from 1992 in the novel written by the author Neil Stephenson. The book, the name is Snow Crash. But after several decades, last year, 2021, Roblox as a company, they referenced the keyword metaverse in their prospectus and identified several key features of the metaverse: identity, friends, immersive, anywhere, low friction, variety of content, economy, and safety. So all of a sudden, the entire industry or the entire world is talking about the metaverse. But to me, as a veteran in the industry of VR, I have been thinking that what is the key difference between the metaverse and the virtual reality? We have been talking for decades. To me, I think they are almost the same. Nothing new. There's nothing new in the concept of metaverse. So here comes my definition of metaverse. this is a restricted definition, and I have another one I will show later. So the restricted definition of the metaverse, in my humble opinion, is actually the key difference or the missing point, that if we only use the term virtual reality, we are missing the missing an important, a most important aspect, which is persistence. So my definition of the metaverse is that metaverse is persistent virtual reality, which means based on persistent virtual worlds, only based on persistent virtual worlds, the digital assets and NFT, whatever you would like to call, will be meaningful and will be probably valuable. But in my opinion, digital assets and NFT, such kind of hot terms, are helpful, but are not necessary, not the fundamental elements of metaverse. So the metaverse is building upon virtual worlds, especially persistent virtual worlds. And of course, in terms for in order for the users to interact with the virtual worlds, we need interaction technologies, especially we need comprehensive senses and actions to allow users to interact with those virtual worlds. And I call those brain-machine interface. Brain-machine interface typically is advanced technology to read your brain and use the signal from your brain to control devices. But in a general sense, brain-machine interface is basically could include everything like the virtual reality headsets or other interactive other devices in enabling any kinds of interactions between humans and the machines or humans and the computers. So that's a brief architecture, but based on that, let me explain our road to the metaverse. So in order to talk about the road to the metaverse, first of all, we need to understand what is reality. So reality, in my humble opinion, is the combination of senses and actions and the world. So the world itself alone is not reality. It's not enough. George Berkeley said that to be is to be perceived. That's why the world itself is not the reality you perceived. The combination of the world and your senses and actions is actually the reality you perceived. So if you agree with this definition, we can look into the virtual reality. From that perspective, virtual reality would be the combination of virtual senses and actions plus virtual worlds, which means we have two dimensions to develop better virtual reality. One dimension is to develop better virtual senses and actions, and the other dimension is to develop better virtual worlds. So with that being said, we could start thinking about what is the ultimate virtual reality. My definition is that the ultimate virtual reality would be the combination of indistinguishable and comprehensive virtual senses and actions, and also self-consistent and persistent virtual worlds. So let me explain this to you. What is so-called indistinguishable and comprehensive virtual senses and actions? Excuse me. So many people are very optimistic about our ability, our current technology, in terms of creating a very real experience in a virtual world or so. But actually, that is not true. So we still we are still facing some grand challenges. This is one example. Imagine you are wearing a virtual reality headset, and you are put into a virtual environment, a virtual bar, drinking beers with your friends. Even if we can fake the look, smell, and taste of the beer, we still are far from being able to create the feeling that you will be high, feeling very excited after you drink alcohol. So that's basically a grand challenge. So we are still far from being able to create a real virtual experience. Not to mention that we are actually today is still far from being able to mimic the smell and the taste. But even with, you can imagine that even with very perfect virtual look, virtual smell, and virtual taste, we are still far from being able to mimic the virtual dopamine, the elements that will make you feel high. So why is that? The reason is that we have made some great progress in terms of some signals that our brain receives, such as sight and hearing. But if you look into that, the reason is that we can create the virtual sight and hearing signals with basic elements such as different lights, different frequencies of sound, things like that. Those are building blocks. But for touch, for smell and taste, we don't even know what are the basic elements of them. And even we know about them, given the example that I just gave you, we're still far from creating those experience, like the interactions between your brain, between your consciousness, and alcohol, and something like that. So, which means we have to change the interface where we are working on. Currently, all the hardware, all the devices, wearable devices, are working on the green interface on this diagram between the outer world and your senses, your body senses. But actually, the ultimate solution would be moving the interface, moving the working interface inside between your consciousness and your senses. So that would be the ultimate interface that we should where we should work in order to create an indistinguishable and comprehensive virtual senses and actions. So that's why I have been talking about that the next the next breakthrough in virtuality has to come from new findings in neuroscience, brain science, and so on. Another example is swimming experience, which is about how to create a self-consistent and persistent virtual worlds. So in virtual worlds, you have seen lots of different virtual worlds. Some are very fine-grained, some are relatively rough. But imagine how you can mimic, how you can fake the experience of swimming. You need to mimic the water. You need to mimic the feeling of putting your body inside the water. So which are very complicated to today's technologies. So this is another grand challenge. We need to be able to create a self-consistent and persistent virtual worlds. There have been some efforts addressing this challenge from different directions. Here are some examples. The very famous Second Life, Minecraft, and Improbable. So all of these examples, they are building virtual worlds with some basic building blocks, so that the virtual world will be running according to its own laws, physical laws, which means it could be it is not only persistent, but of course also be self-consistent. So that's the key to eventually being able to create the swimming experience, which means our virtual world need to consist of building blocks, and those building blocks will interact with each other according to some physical laws, not necessarily the same physical laws in our real world, but some self-consistent virtual physical laws. So that's another direction and another grand challenge. With that being said, this is my prediction of I would say the road to the metaverse. So one direction is to be able to achieve indistinguishable and comprehensive virtual senses and actions. Today, we are already able to achieve read-only brain-machine interface and simple actions, which means if you are wearing some EEG headset, it could read your read the rough signals from your brain, and you can just by thinking, you will be able to I would say type in characters and controlling toy cars, things like that. My expectation is that in 2025 or earlier, we would be able to improve the I would say the depth and the of the brain-machine interface signals, so that by reading the signals from your brain, you will be able to do any actions through such kind of brain-machine interface devices. But the most difficult part is to write into your brain. So read-only is not really very difficult, but write is much more difficult. So my expectation is that by 2035 or earlier, we will be able to have read and write brain-machine interface technologies, which means all kinds of senses, your sight, hearing, touch, smell, taste, emotion, things like that. All kinds of senses can be mimicked by using some brain-machine interface writing functions, writing signals into your brain or your consciousness. And the other direction is, like I mentioned, is a self-consistent and persistent virtual worlds. Today, like the examples that I just gave you, will be able to provide building blocks like the virtual bricks and blocks. And along with the development of our computational power and so on, our expectation is that by 2024 or earlier, we will be able to improve the details to down to the virtual dust level, and later by 2027, we can probably likely improve the details down to the virtual elementary particles level. So that's our expectation, or in other words, our forecast of the technology. But the best way to predict the future is to create it. So we need to do lots of things to make it happen. And we also need to leverage things like standards and other ecosystem tools and collaborations to make it happen. So here's another definition of metaverse, because we are talking about digital transformation, which is the umbrella of today's session. So many people have different understanding of the metaverse. So I think a general definition is that today we have so many vertical industries using different digital technologies for the digital transformation. So it's very reasonable and predictable that along with the advancement of digital transformation in different industries, eventually we will get into a stage of convergence. So the convergence of digital transformation in different vertical industries, eventually the advanced stage of digital transformation will be the long-term vision of I would say our society, our industry, and our world. That is the long-term vision called metaverse. So that's a general definition. So in order to pave the road to the metaverse, there are multiple efforts on the IEEE. I just mentioned a few of them. We have the VR and AR Standards Committee under the Consumer Technology Society. Under that, we have two working groups. One is the VR and AR working group. Under that, we used to have 12 projects, but for now, those we are under a reorganizing effort. So those projects will be revised and revitalized later. And we have another working group. It's called the AR on Mobile Devices Working Group. They are working on the standard 2048.101. And those are about standards development. Beyond that, we have the VR and AR Advisory Board, which is working on things more than just the standards development. And we also have a global initiative on ethics of extended reality. I call that what they are doing is more than technical aspects. They are addressing non-technical aspects like ethics. So those are just some examples of the efforts on the within IEEE, and we definitely have more. For example, today we have another speaker, Roberto Sarraco, who among his many roles, one of his roles is co-chair of the IEEE Digital Reality Initiative, which is also focusing on digital twin and so on. So I'd also like to make some announcements about what we are doing. Some are IEEE efforts, some are non-IEEE efforts or joint efforts. So one is a series of metaverse landscape and outlook reports. So we're currently working on 3 reports in a row. The first one to be released in May is the metaverse in the eyes of top experts. So we invited 11 experts all over the world to provide their definition, understanding, and forecast for the metaverse. And the second one will be the metaverse landscape and outlook, technology patterns and standards, planned to be released in August. And finally, we are planning the third episode is the metaverse landscape and outlook, market and investment. It is planned to be released in November. And excuse me, we're also planning launching a new organization called the Open Metaverse Initiative, which will consist of 2 parts. one party we tentatively call that Open Metaverse Federation. It is planned to be an IEEE ISTO program and a 501c6 nonprofit alliance. It will be entity-based and will have its own organizational structure. And another one will be an individual-based open metaverse community, which will be a nonprofit, decentralized autonomous organization, DAO. So those two organizations working together will be dedicated to the so-called Open Metaverse Initiative. Our goal or our vision is that metaverse should be the metaverse effort or the metaverse development should be open to everybody. We should encourage global open collaborations so people could working together to design, develop, operate, use and benefit from the metaverse. So that is our plan. So I will keep you posted. And finally, this is my contact information. You could contact me or keep watching my LinkedIn and other social media channels for news regarding the metaverse and my efforts in the area of metaverse. Okay, so that's the end of my presentation today. I see some questions in the chat window. Okay, one question is from Tom. The question is, when are we able to write information to the brain? What can be done to let the brain be written to know that this is information from outside and identify the source? Well, I think technically we don't have the we don't have a clear answer for now, but I assume there will be a series of privacy and security technologies to support that, so that while we will be able to allow our brains to be written, we should definitely be safe and without any compromise in terms of our safety and security. So I assume we will need a series of technologies and standards to before we can do that. And of course, some ethical considerations will be needed as well. Another question Tom put in the chat window is, how can we avoid even more immersive echo chambers when information can be put directly into the brain? Well, I think that is sort of like a societal question, and that is a good question. Of course, if I understand that correctly, people can choose what kind of immersive environment they want to stay in or live in. But of course, we may have some societal considerations on like if that is really good to the people, if that is really a good thing to the humanity. So such kind of so myself is a strong believer of the so-called life is elsewhere. I think the realities could be boring, but we could make people more happy or more productive or more, I would say, with more possibilities by providing positive virtual experiences. But of course, it is also possible for those virtual experiences to have negative consequences. So that's why we will need ethical considerations. We will need standards, and we will also need to work with the rule makers to avoid such kind of risks. I hope I addressed your question. Tom, what do you think?
Yeah, no, I think that's in other words, I think there's some interesting opportunities there to develop responses before there are issues, or at least the beginnings of responses and methodologies. Thank you.
Thank you, Tom. Okay, let me say, do we have other, oh, we have Lee on the line, okay, and Roberto. Great. So Lee, it's your turn. Let me introduce you while you are preparing your slides. Let me stop my sharing. Okay, 1 second. So our next speaker is Lee Stogner. He serves in executive positions in several corporations that drive improved business performance using technologies that include business innovation, digital transformation, project management, IoT, and artificial intelligence. Among his many roles, he used to be on the IEEE Board of Directors and the Region 3 Director. And he's currently serving as the chair of our IEEE Association for Digital Transformation, and also the IEEE chair of the IEEE 2023 Digital Transformation Working Group. Lee, the floor is yours. Are you ready?
Yes, I am. Can everyone see my screen?
Yes.
Very good. And I guess you can also hear me. Wonderful. First, let me apologize real quick. All those things happen when you rush to get things going. And I came in at 10 till the start, couldn't log in. So Ralph Ma and I spent an anxious few minutes trying to fix things. It never worked. And then all of a sudden it just started. So take my apologies and let's get started. Welcome to the World Digital Transformation Conference. I'm going to be doing the introductions as well as a digital transformation overview. And like Yuan just mentioned, I'm the managing partner of a consulting group called the Winkler Group. We do management consulting and digital transformation, sustainability, and other related issues that the digital transformation world enables. So with that, let's get into the presentation. And I'm counting on Ralph to tell me when to stop. See, it's 10 after 10. So first off, today's agenda. Yuan just jumped in. Thank you, for giving me time to fix problems. We're going to have a number of speakers talk about various aspects of digital transformation and how each one as a technology vertical supports the rest. So Yuan just did the metaverse. Tom Coughlin will be talking about the memory of artificial intelligence and how it relates to digital transformation. Roberto Sirocco will talk about digital twins and their role in digital transformation. Ray Sheen will talk about digitization, its strategy roadmap, and then lastly, Alex Lee will host a panel where we talk about metaverse as a super accelerator of digital transformation. So, starting point, I always like to have the means to communicate with my peers and other people around the world. So let's have a common definition for digital transformation. And I'll read it just to make sure you hear it the way it's intended. Digital transformation is the adoption of digital technology to transform services or businesses through replacement, non-digital or manual processes with digital processes, or replacing older digital technology. And I'm old enough to be around where we were just absolutely excited when we could connect two boxes together, just connect them. And that was in the late 70s. And digital transformation is providing the means and the ways to connect not only boxes, but boxes worldwide, and then layer applications on top of it. And this particular definition came from Wikipedia, which I think is a pretty good definition. Starting points. Lots of things are happening from a timing standpoint. The fourth industrial revolution has begun, and that is a grand aggregation of technology and people and training, experience, and then lastly, the right applications at the right time. Business sees the economies of all of this, and they're going connected and fast-paced. And it's important to understand the people aspects. As we learn through the world of Lean Six Sigma and other business improvement strategies and methodologies, you can't just rush in and install a bunch of new computers and then tell the big boss, hey, we've done our job, turn on all the benefits. You can't do that, because when you do that, you leave out the people. They see the big boxes rolling down the hall, and they see their jobs rolling out the big hall. So people first, training, culture, and then the technology of digital transformation, metaverse, big data, and all the rest. So lastly, I like the Arthur C. Clarke quote, "Any sufficiently advanced technology is indistinguishable from magic." I see a lot of magic in what we're doing right now. So let's orientate all of this together. You know, some years back, as we improved the networking that I experienced back in the late 70s, to the point where boxes and applications were talking in a serious way, we said, well, let's give it a name. That name is the Internet of Things, and it provides that magic, if you will, foundation for all these things that are working together and allowing us to talk and exchange information and make those applications get synchronized and beneficial to the improvement of society, industry, and the things that we wake up tomorrow morning and say, let's go try that. So if you look at our progress from industry one, just having mechanical things replace the hands of humans and give us efficiencies and repeatability. You had things like mechanical looms back in the 1700s, and then forward ahead a bit, we introduced a division of labor and mass production with something called electricity. And if you look at the world of climate change, we're doing it again. We're trying to replace all energy and replace it with the things you can do with electricity. Thirdly, the industrial revolution. We brought in our programmable controllers, our microprocessors, our mini computers, and allowed them to collect information up and down the process stream to know what's happening all around a particular machine or process center, and synchronize and make sure that production schedules we established early in the morning, we can actually make things happen and at a quality level that the customer will pay money for. And then lastly, the fourth industrial revolution. We are knee deep in that right now, in which we're combining AI, mass production, smart sensors, everything together to give the machine, the process, the plant, the group of plants, the integrated knowledge and coordination to do big things such as produce parts anywhere in the world, and then bring together those parts, lastly, into assembly plants and build things that we all want to buy, which is cars and other things like that. So here's where we are. There's some people say we're about to go into the fifth industrial revolution. I think they're right. But let's make maximum impact from what we're in right now. We've had different ways of applying labor and automation to the making of things. And in and around that, we've got things like Lean, Six Sigma, becoming Scrum experts. All these things require people, teams, relationships, innovation in the front end to drive the development of new ideas and the things that we can refine and build. And all around it, the procedures that allow things to be done together all over the world. And then lastly, that equals project success as we get everything to work correctly together. Pathways to digital transformation. If you go from the left of the screen to the right, again, we're identifying how to make sure people are used to the maximum. That's good for them. It's good for the facility and the goals of the plant. That the processes are synchronized such that you develop, pilot, test, scale, integrate, and then cross over to make sure we're doing the right things at the right time, and then learning for what we just did to make sure that we do it better the next time. The next time could be after lunch, tomorrow morning, or we restart this particular product to make more of it. And then lastly, make sure we're using the appropriate systems and human architecture such that we coordinate efficiently and maximize what we can do. Together is the magic word. So what are the drivers for digital? Certainly productivity increases, connected work, mass adoption of mobile devices where you can collect information in real time down at the spot where work is taking place. Job descriptions are going to change as we become more efficient, and the organization is able to do more together at a higher rate of quality and at a practical cost. We're pushing our data and apps to the cloud. We now have machines that span the world through the networks and the ability to use this information. We call them enterprise apps. You'll see more of that in a few slides. And in the cloud, a lot more people can share the information. A lot more people can provide their input and their value into those applications that run up in this, I'll use the word again, magic cloud. Edge computing, smart machines, the autonomous vehicles that are always 5 years out. Data standards. If we're going to design something, say, in Beijing and produce part of it in South Carolina where I live, or Munich where other folks live, we've got to have standards such that we measure things together, both at the standpoint of the design drawing and also from the standpoint of you have to measure to determine did we do it correctly. Standards give us that language and those references to make sure we're doing the right things at the right time. And then lastly, we could have put this at the very beginning of this list, the workforce. We've got to make sure we're doing the right thing by our people, because they're the entity that give value to everything that we do. So here we've got sort of a demo that you can sort of visualize in your mind. Way back when, visualize that travel took weeks by horse and days by train, and then telephone to move things along faster. And now something called Zoom that we're using right now, not always perfectly. Remember, I came in a half hour late, and all this works to improve the idea, the design, and the means for producing product and services. Manufacturing, way back when, I guess the Henry Ford example works for most people. We were doing a lot of things on an assembly line such that we could produce more and with a measurable repeatability and quality. Now, sometimes on that Henry Ford production line, people were using hammers to make sure that part was okay, and the rough edges were beaten out of it, but things got faster. And we did it through the standards. We do it through 3D printing. We do it through laser scanning in the means to know what we just did mechanically, chemically, or just simply what we have to do at one step is what the next step is expecting. So we'll plug into whatever they're doing to add additional value. And then lastly, in our demo, local doctors used to be the only way for immediate care. And now a doctor can visit anywhere in the world, see what the situation is, and even provide surgery. I hope this saves more people and brings the cost of medical care down further and further. So before we can process and promise everything that we're telling management and our customers, we have to have a methodology that says what I do today, I can repeat tomorrow, using all the metrics that we're talking about right now to design repeatability into the process. Number one is the cultural change. Number two is we've got to make it financially possible such that we can take the risk, not only for the company, but for you and I as engineers or production managers that need to work on what we are promised, along with folks elsewhere in the company or no matter where. And then the owners need to take the lead. This is a busy screen. I don't expect you to be able to read it. You might see some of it, but this is a project delivery methodology that if we do all these things in the right order and to the detail you see, we're going to produce product or that service the way we are promising the customer at the price and also the delivery time frame that makes all this possible. So from left to right, we have to assess the opportunities. We have to define what it is we're trying to do. Then we design the product or service. Then we develop how we're going to make it and what the supply chain might give us in a daily fashion. The next to last is integration. What I do needs to synchronize with what you're doing. And then lastly, feedback. Make sure what we're learning goes all the way back as many steps to the left as we need to make sure we're learning from what we just did and the process and the product is continually improved. Digital transformation industry. If you want to be an entrepreneur, this is a great place to visit and learn from. Most of these companies that you see in front of you on the screen did not exist 5 years ago. 10 years ago, they were just an idea in someone who was going to school's mind, or someone who worked for a company and you always told yourself, we can do this better. So digital transformation and the industry that it continues to spawn is a great place to be if you're an entrepreneur or if you want to do things simply better at a value and a price that the world will come to your door and buy from you. Given that the audience for this particular session is mostly Asia, these companies were born and grown in your neighborhood, down the street, or in the country next door. This is impacting the way you live, the rewards you can bring home to your family. This is where it's happening. So these kinds of companies are very smart in terms of the world of digital transformation. You might want to consider working for one or create something that can provide a service or product to these customers. Okay, I mentioned the word enterprise earlier in my 30 minutes. And these are things that happen. The information is collected from all over a corporation, and the corporation locations can be anywhere in the world, and uploaded to this magic cloud in the sky, and then the information is put into the proper place in the database, and then the algorithms understand what's going on left to right as the company does its daily job on a schedule to a quality level that allows them to exist and continue to grow. A different view of the enterprise. This is a bit more visual in that you can see process centers, you can see production lines, you can see people all working together. And I like to use the left to right flow of things. And here's steps in the company as they make things. as they provide information, as they do things to provide the expertise or the work that the customer is expecting. So, Yuan talked about the IEEE. I'm a longtime member. I've been on the big board. Yuan is now on the big board, and it's a nice organization to be a part of, to learn from, and also help it grow in various ways. So right now, IEEE is very involved in digital transformation at several levels: training, conferences, publications, conferences, workshops, webinars like we're on right now. And we're looking for even newer ways to train and connect with a base of members worldwide. We've got about 400,000 members. A number of them are involved in the two magic words of digital transformation. We're doing standards. The standard that we're working on right now that I'm the chair of, P2023, we call it a collection of frameworks that are going to allow different people and what they're doing to work better together as we use the digital transformation umbrella over all this, if you will, applications below that umbrella, and then a foundation of IoT. And we're trying to drive integration with other organizations. Here's a screen from the website for P2023. It's a group of people. We meet within committees. We meet monthly as a bigger committee and doing the work that's going to take our ideas, put it on electronic paper. So in another year or so, we'll have this standard that will be a living document to help people do things under the philosophy of a standard to the detail that we're creating with P2023. Now, if you can, there's a line not quite at the bottom of the screen where it talks about some of the various chapters that are being created and put into this standard. I'll read them for you, left to right. Artificial intelligence, augmented and virtual reality, blockchain and DLT, cloud computing, connectivity and telecom, IoT, manufacturing, mobility, networking, internet. And I'm sure more things will come up in the days ahead, such as edge computing, digital twin that you'll hear from Roberto on. This is a living, growing document, and we want to make sure it's a useful document that people can use to organize and understand the work ahead. We are creating an association. IEEE standards give us the authority to create the IEEE Association of Digital Transformation. It will be member-based. You'll see a lot more of this towards the beginning of summer, and it gives us a place to go work together to focus on training, lots and lots of implementation, and those applications that take what we're doing up a level such that we have the tools, the software, and the inherent procedures and application knowledge to make all this work together anywhere in the world. We are either identifying or about to create practical tools, resources, and that magic word called methodology. Conferences, workshops, publications. Yes, yes, yes. Industry involvement. Academics can't do this by themselves and then throw what they've done over the wall. We need from day one involvement by industry. The companies you saw on the charts a couple of slides back, they're at the table with us right now to help us decide what we just did is correct and to lay the groundwork for the next step and the steps after that, and to make sure we can do it anywhere in the world. What we're doing has to be international in scope. Thanks to Roberto and his team, a book was created back in November 2020. You can download it as you get a copy of these slides. You can cut and paste and download a copy of this document. It's several hundred pages. It's a lexicon of words and definitions of how we need to talk and communicate, all about digital transformation. Thank you, Roberto. We have publications. If you are aware of a platform called Flipboard, I collect daily articles and other information that have been created, and I put it into this online magazine. You can view it through your PC, your Mac, your iPads, your mobile devices, and I think you'll find it informative and timely, such that this won't be a once a day or a once a month application to go find out what's going on and who the players are. You'll check it out often. So, digital transformation by IEEE. Now, under the umbrella of digital transformation, there's various applications that we mentioned, again, a slide or two back. One is IoT. This is another Flipboard magazine that gets into the detail of what's happening in IoT. Please read all about it. Tell us what we can do better. IEEE blockchain. This is sometimes a mysterious application, but it's starting to do a lot of work, and it's giving people the way of coordinating a lot of activities in the right order with secrecy of and privacy where required, but also quality in the sheer amounts of information that can be transferred along as you design things, you buy things, you ship things, you make things, and you use things. It can be a product, it can be a service. Blockchain has a tremendous application around the world. Here's the dashboard. You can go to flipboard.com/@Stogner. That's me. And here are the main technology verticals that come under the digital transformation umbrella. All of these things you need to keep an awareness of, and then dig into one or two for information for whatever you're doing in the world of digital transformation. Questions? We are looking for volunteers. We're at the point where, as we create the standard P2023, we're going to need more than simply the people that created the words. We need people to help us review. We need people to help us understand, did we miss something? We need people to help us understand, are there applications beyond what we conceived of at the beginning of this development that, with a little tweak here and there, can be applicable to more and more things and activities around the world. So there's my address. Please write this down. Yuan and Ralph will be providing electronic copies of all this, so you can learn more about the standard and how to stay in touch with us and make sure that you can help us, because this is quickly going to ramp up and require more and more people. And with that, Ralph and Yuan, the next person in the queue should be ready to take up what I'm finishing right now.
Thank you, Lee. So let's save questions to our panel discussion. And our next speaker is Roberto Sarocco. Let me introduce him. Roberto Sarocco
I
is
will stop my chair so Roberto can.
Yeah, you just stop sharing. Yeah, so while you are stopping sharing, let me introduce Roberto. In Venice, looking at the interplay of technology evolution, economics, and society. And he also used to be leading a World Bank info development project to stimulate entrepreneurship in Latin America. And Roberto is currently a co-chair of the IEEE Digital Reality Initiative, fostering the digital transformation. He is a Comsoc distinguished lecturer, and he used to be the IEEE Technical Activities Board Future Directions Committee Chair, and now he is chair of the IEEE New Initiatives Committee under the IEEE Board of Directors. He has published over 200 papers in journals and magazines and 30 books and ebooks. According to my observation, if you find the digital transformation or digital twin in the IEEE, the ILN, IEEE Learning Network, most of those learning modules were produced by Roberto. So in my opinion, he is our Mr. Digital Twin or digital transformation. So welcome, Roberto.
Thanks a lot. You're very kind. I hope you can hear me well.
Yes.
Okay.
Yes, go ahead.
Okay, very good. It's a pity that I cannot see all of you, because that would make my life much more fun to see your face. Anyhow, I'm going to talk about digital twin role in the digital transformation. And you see here is my email. Please connect with me, send me your thoughts, and we can discuss even offline. So basically, the digital transformation, we have already seen the definition of Lee, which is a very accurate one, by the way. But let me give you a different interpretation to this, a more operative one. When we're dealing with digital transformation, what we do, we start with the physical world, which is represented by atoms. And by using sensors, IoT, we are transforming that into digits. And we move into the cyberspace in the world of bits. And this world of bits is quite different from the world of atom, because if I have an atom and I'll give it to you, you've got my atom, but I no longer have it. But if I have a bit and I give you my bit, you have it, and I still have it. So this is a shift from the economy of scarcity to the economy of abundance. And this is changing the rule of the game in a way, okay? Now, when you are in the cyberspace, you have all these bits, and these bits are mirroring and modeling the physical reality. But you can also connect very easily all these bits to try to understand what's going on and so on. Well, we are embedding all of this kind of thing into something that we call the digital twin. And the digital twin resides in the cyberspace. However, by using augmented reality, we can connect the cyberspace, most of the time using the digital twin, to the physical world. And we can also use the digital twin as a sort of avatar to walk through and to walk in the cyberspace. Now, this shift is affecting everything: products, processes, business model, and you name it. Now, the laws of economy do not change, okay? Many times I read on newspapers saying, oh, we are in a new world, in a new economy, okay, the new economy. But that is not true. If you studied the economy 200 years ago, you can very well apply the very same rules to the economy of today, to the digital economy. The difference is the fact that the marginal costs in the digital economy are very low. Actually, they are approaching zero, because you can duplicate for a bit at zero cost, you can transmit bits for zero, and so on. And the problem with the marginal cost is that they are influencing the end price of your product or your service. Now, if the marginal costs are tending to zero, it means that also in a competitive space, your product price will go to zero. And this is the huge implication. And you see here in the image a list of many applications, and you can get all these applications basically for free, which is something amazing, okay? Because each of these applications costs a lot of money to be developed. Now, we are in the cyberspace then, and we are dealing with data, because data is what we have in the cyberspace, and then functionality, how to manipulate this data. Now, what can you do with this data? Well, data are a commodity, basically. They have very little value unless you make them become scarce and you move back into the economy of scarcity. How you do that? Well, there are different layers of data. You have data that are describing a certain situation, like you have a camera, a video camera on a crossing point on a road crossing, and you see that there's a traffic jam. Okay, this is descriptive analytics. And then you ask yourself, what happened? Well, all these cars are coming together, but why did it happen? This is diagnostic analytics. and you need more information about that. You need to correlate it something, and then you can do some simulations and sort of predictive analytics. What will happen? And here you start to making really value growing out of data. And then of course, what you want to do is to take some action, okay, some proactive action so that you can change the outcome of a certain situation. And that's where really the value is. Now, you can do this kind of thing in different ways, of course, but the digital transformation is basically about this sort of creating value out of data. And you see in this image that you have there, you're basically starting with the digitization, which is the transformation of some physical entity into bits. And this, of course, makes possible to do some automation to processes and to the activity you're doing. And then you move up one step and you are going through the digitalization. And digitalization is about moving your processes and your activities in the cyberspace. And you're doing that, of course, by changing your process, because doing process in the cyberspace doesn't really make sense to have exactly the same process as you're using in the physical space. And this is done through the process of re-engineering. You're increasing the value, you're creating a more effective company by doing this kind of thing. Now, most companies have gone through these two steps, okay? And many of these companies are claiming that they did the digital transformation, but that's not the case, okay? They just digitalization, and they stop there. But by stopping there, they are not taking advantage of living in the cyberspace. And taking advantage is really what is about the digital transformation, creating new business model and creating new opportunities, enlarging your offer portfolio. This is where we really want to go, okay? And in order to do that, you need to consider all the aspects of your company. You see in this graphic here, you're starting with a tiny place in your company, with a work group, a single process perhaps. You start to understanding the process, and then you want to improve the process, okay? And by improving the process, most likely you're also going to affect other area of the company. So the line of business, the business area, and so on. And then you go farther, okay, up to the point that it becomes a transformation of your company. Is the business process re-engineering, business process management. And that is the point where you want to go. And that is what we call the digital transformation. Now, the digital twin are playing a significant role in this thing. Now, look at this picture. This picture is taken from a Mevea. Mevea is probably one of the first and one of the best company if you want to explain a digital transformation. They are a Finnish company, and they are working in the area of the big machine for big and small machine for operating on roads, digging trenches, building buildings, and so on. Now, what you see there is a customer, okay? And what is this customer doing? Well, this customer went to Mevea and asked Mevea to build a specific machine to operate in a specific environment. Imagine in Venice. In Venice, we have very narrow roads. We call them calle. And the usual machine that you find on a portfolio of Caterpillar or these big companies won't fit in this kind of narrow environment. So they went to Mevea, and Mevea sent some of their technicians with drones, and they took photogrammetry of the area. And then they built a virtual environment, of a virtual space of that area of Venice. And then they built a digital twin for the machine that will be built. And now they are at the stage where they have the digital twin of the machine, they have the virtual environment, they are calling the customer and saying, okay, operate the machine. But actually the customer is just operating the digital twin, okay? And he can tweak the various functionalities. He say, okay, this works, this doesn't work, I want something different, and so on. Once it reaches the point that the digital twin is really representing what the customer wants, so we're still in the design phase, then Mevea says, okay, let's build it. And they are using the digital twin to go to the CAM, computer-aided manufacturing. They build a machine, and they deliver the machine. And the machine is delivered with the digital twin attached, so that when the customer is using that, the digital twin will follow up what's going on, and Mevea can interact and see if they can upgrade the machine by providing additional functionalities and so on. So the digital twin starts from the design phase and goes on into the operation, ensuring that you are really fine-tuning the product to the desire and needs of the end customer. Now, look, this means that Mevea is no longer selling a product. They are selling a product along with a service. And this is the digital transformation. They have transformed their business into being a product delivering enterprise into being a service delivery enterprise, even though they are still delivering a very, very hard product. Now, the overall evolution of digital twin has been from a first stage where you just add the digital twin as a model, you're designing the physical version. It moved into the second stage where you have the digital version flanking the physical version, and you were using the digital version to do some simulation to try to understand what was wrong in the physical version. And then now we're basically in the third stage where the digital version is communicating with the physical version and the other way around, so that the two are actually working together. And we're already seeing some cases where the two are overlapping, which means basically that the digital version is also being used in real time to provide some of the functionality that makes more sense to create and operate and deliver in the metaverse, in the cyberspace. And they are working together. The fifth stage will be when these two things will basically also be able to work autonomously from one another, and you can perform something in the cyberspace autonomously, something in the physical space, and they're coming together to work and implementing something in the physical space. Now, as application of digital twin, we have several, of course. They started from manufacturing, so that's the reason why I mentioned this for the first one. And you see, you have this diagram that was developed by Deloitte, but basically the tooth of the metal, the digital and the physical, are joined together, and this joining together is achieved through the digital twin. Now, the digital twin becomes an instrumental bridge between the two worlds. And this is also the things that you're using to implement, to execute the digital transformation on the physical products, because then you're keeping the product in line and connected to the cyberspace. And of course, for doing that, which is part of the Industry 4.0 in manufacturing, you're also using a need life cycle platforms such as MindSphere from Siemens. They are providing you this platform that allows you to develop a digital twin from the very first design stages, to use it for the manufacturing, and then to use it for the operation, and finally for delivering services, additional services. Digital twin are being used as an example by Arup in this image for construction. They've got construction in 150 and more countries, and they are using digital twin to monitor the construction and then to deliver services for operating the various building, understanding how the conditioning works, how much temperature and waste is related to a certain type of construction. And they are learning from experience through the digital twin, so that they're using this kind of knowledge and learning for the new construction that they will be making. You can use digital twins in smart cities. And here you have an example of Singapore that was the very first city to create an overreaching digital twin. And starting January 1st, 2019, they are operating the system, the city and its infrastructure through this digital twin. And here you see images from Dassault that were one of the companies that provided Singapore with this kind of technology. And then we've got the application of digital twins into healthcare. And Philips, as an example, here you have this image from Philips that is using physical devices, digital twin to follow and to operate this kind of thing in an hospital, make it more efficient. Probably the first one to use in healthcare digital twin was General Electric. And actually, in one of their presentations some few years ago, the director of the healthcare division said that the future of healthcare is going to be connected with digital twin. And interestingly, they have developed also digital twin for patient. So not just for the equipment, for the MC scan or whatever, but also for the patient. And this kind of development has been acquired by pharma's companies that are using this kind of digital twin, generic digital twin, for simulating the effect of a vaccine. And we have seen it applied for the COVID vaccine development. But also they are starting to instantiate this digital twin to a specific patient, so that they know exactly for that patient, getting the information from the exam, from the genome, and all this kind of thing. And the working of that patient from a physiological point of view, okay? And this is creating an image of a single person. And this is leading us into personal digital twin. And you see from this image, what we have is that industry is leading the way with the digital twin. But out of that, we're starting to use digital twin in healthcare, and this has generated the personal digital twin. And we are seeing more and more evolution in other areas, like in retail and now in education. And in education, what we are heading at is the development of cognitive digital twin, that again, they were born out of manufacturing. IBM used those for robots. I'll come to that. Slightly different from normal digital twin. They are a little bit more unpredictable, okay? You can model a machine, and if your model is right, you know exactly what's going to happen and what that machine is going to do. If you model a guy like me, you might find out that you're expecting me to do something, then I'm doing something else, okay? So I'm much more unpredictable than a machine. So there are different characteristics related to personal digital twin. As we are increasing the level of fidelity, okay, we're also stepping into more and more difficult, trickier ethical and societal issues. And at the Digital Reality Initiative, we are addressing this kind of issues. We've got people that are not at the ethical side, that are helping us in understanding what the implication of this kind of things is. But the interesting thing is that once you're talking with a personal digital twin and you are at the second stage, basically you have a model, okay? And you can use that in the pharma as an example. But then if you're connecting these two things, the physical and the digital twin, you can use the digital twin as a prosthetic. Okay, you are missing some point, you don't know something, and you turn to your digital twin to get the complementary features that will help you navigate the world. And finally, we can reach a stage, we are not there yet, where the digital version of myself and myself are so overlapping that I no longer perceive that there's a digital me, but I just perceive me as an ensemble of the digital and the physical version. And this is resulting into an augmentation, okay? I'm augmented. And once you reach the fifth stage, what happens is that I can detach my digital twin and I can achieve the level of ubiquity. I can send my digital twin everywhere. I can duplicate my digital twin in many instances, and I can talk to many people at the same time. Okay, so this is for the future, but this is clearly a line that we are seeing. Now, what we're also seeing is the fact that these personal digital twins are being used, and they have been used in the Far East, in Korea, China, and so on, for monitoring, controlling the epidemic. What we did at the Digital Reality Initiative was trying to find out an architecture that would allow the personal digital twin to act as a bridge between the person and the community and the society. And by doing that, it could preserve the privacy of the individual towards the benefits of the society. So how does it work? Well, you see here the scheme. Basically, you have the healthcare institution that is telling something to the personal digital twin. The personal digital twin talking with the physical twin, myself, my body, knows that something is going on with me, and based on the information received from the healthcare institution can warn me, well, you're stepping into an area where there's a high risk of contagion, your coughing is getting worse, and is getting similar to the cough of somebody that has been infected, so pay attention. And it can raise a red flag to the healthcare institution saying, hey, there's a guy, it doesn't tell it's me, but there's a guy in this area that is likely to be infected. And based on this kind of information coming from many, many people, the healthcare institution can evaluate a risk level in a certain area. Now, the authority is there for fixing the rules. And they might say, well, if a risk level in a certain area is exceeding a certain threshold, then people should stay home. And this information is percolated to all the personal digital twin, so that the personal digital twin knows that if it happens to be in an area that is subjected to lockdown, it should warn the person that it should be stay home. Up to this point, nobody knows who I am, where I am, and something like that. However, if I'm stepping out of my home and I am supposed to stay home, then a red flag is raised to the authorities saying, hey, this guy is getting out, whilst he should be staying in. Now, is this a violation of privacy? Well, yes, but it's the same one when you're falling into a speed trap with your car, you're overspeeding, and they catch your plate and they send you a ticket. Okay, so it's the same, exactly the same ticket. But if you're not overspeeding, you go through the speed track and nobody's paying attention to you. Now, the next step that I already mentioned is the cognitive digital twin. Personal digital twin is modeling myself as a body, okay? But what about my mind? What about my knowledge? Well, this is the cognitive digital twin, and it was born, as I mentioned before, by IBM, with the idea of creating a sort of knowledge space for robots in a company. But robots are getting smarter and smarter. They are becoming autonomous. So they have knowledge. And this kind of knowledge is the knowledge they have, the knowledge they have about the environment, and the knowledge they have about the other robots. And having this kind of knowledge, they can interact much better, more efficiently. So this is the point that led IBM in 2018 to create this concept of cognitive digital twin. Now, we took this concept and we adapted it to the education space. And we actually used this kind of thing in our digital reality initiative to see how can we model the knowledge of a person, and how can this model be used to the advantage of the person? How is it going to change the relationship that our members at IEEE have with knowledge, or people, workers have with a company? A company is actually a virtual knowledge repository, okay, composed of machine, composed of processes, and composed of people that know something, okay? Now, having the possibility of knowing what their people know, it's a great advantage for a company. And SAP is actually very much interested in this kind of thing, because they are modeling resources in an enterprise, and knowledge is a certain kind of resources. Now, we can see the evolution of this kind of knowledge digital twin moving to stage one, where it's just a reflection of the type of knowledge, to stage two, where there's a continuous flow of knowledge between the company and the person and the repository. It may be the repository of IEEE, to stage three, when the people can actually be augmented by the knowledge of the company or by the knowledge possessed by the IEEE. So this is the kind of evolution that we are pursuing, and we have created an application that is called Knowledge as a Service. This is a prototype stage, but it's already working, and you can access to it and create your own digital twin as a person or as a company, okay? And the knowledge that we have embedded is the 14,000 knowledge entities of the IEEE ontology. And you can pick up this kind of thing and cluster and say, okay, I know this kind of thing, I know that, and so on. And then you can use this kind of thing for filtering, for making a much more cleaner and better, more efficient access to the knowledge in the IEEE Explorer. But you can also use this kind of thing to try to understand how is the world evolving with my respect. Okay, I'm going to need this kind of knowledge, and what kind of knowledge is existing out there, and what kind of gap exists between the knowledge out there and my knowledge. Now, all of this thing is really a crucial aspects of the digital transformation, because the digital transformation is not about just machine. It's also about people. It's about the processes connecting people with machine in a company. And so a company that goes through a digital transformation process should also pay attention to how to leverage the knowledge of their people, and how to embed and mix this knowledge with the knowledge in the company created by robots, by artificial intelligence, and so on. And we're actually looking at an artificial intelligence, an AI, that becomes an IA, which is intelligence augmentation. And this intelligence augmentation can be achieved through this personal cognitive digital twin. Now, you can go deeper and you can get much more information. by looking at the kind of papers that and documents, white papers we have been publishing in the DRI initiative. You can get IEEE courses. We've got some 120 modules in this area, and you may want to follow my blog. Every single day I'm publishing something about this topic, and you may want to look at other companies like the EIT Digital, that is a European organization that is focusing on helping companies to achieve the digital, to execute the digital transformation. Or you can use the innovation operative network that is there in their business is to help companies in executing the digital transformation. Thanks a lot.
Thank you so much, Roberto. This is a very visionary overview about the digital twin. That's the best I've ever heard. Thank you so much. I assume for the interest of time, we need to go to our next speaker. Our next speaker is Ray Shane, who is the president and the founder of Product and Process Innovation. And he is a veteran business leader with over 35 years of executive, functional, and project management experience, delivering training and consulting on 3 continents and over 15 countries. He's also a fellow at the Institute for Digital Transformation and a member of the PMI Project Management Institute. Ray, please. Ray, you are probably on mute.
How about now? Is this okay?
Good.
Okay, good.
Yeah.
Thank you, Dr. Ahn. I appreciate that. I appreciate the other speakers. We'll be able to build on some of that with what I'd like to take a few minutes and discuss, which is now bringing all these together and creating your digitalization strategy roadmap. We'll talk through some of the elements that are part of that roadmap, but I just think it's interesting that we've seen the combination of the metaverse and the digital twin, and looking at some deep dives into things like the memory, and understanding how we can bring all those together in a way that's going to help us move our organization forward. As was mentioned, I'm a member of the Institute for Digital Transformation. I'm also a professor at Worcester Polytech Institute. I've been involved in research and development in government labs, industry. I've worked with nonprofits. I've seen a lot, done a lot, and I'd like to share some of my experiences on that, and also provide a framework for you to move forward with your transformation. Now, disruption is something that's reality, and we've already heard and seen some things. Lee brought out some very important points of that earlier, but there's disruption. It's everywhere within the world we live in today, whether we're talking economic disruption, geopolitical disruption with wars going on several places right now, regulatory disruption. We have some of the new taxonomy in Europe. We've got the ESG happening in North America. So we've got a number of new regulatory initiatives that are coming in. And then, of course, workforce disruption, the most recent being the pandemic. But there's been other things that have caused movements of workforce, changes in workforce. All of those are creating a lot of disruption for us. Disruption creates both opportunities and threats. Now, if we look at what our organizational response to disruption, it'll take one of 5 different responses. One response would be just ignore the disruption altogether. Don't pay any attention to it. Assume it's just going to be a quick passing wave. It's a fad. You can ignore it. The trouble is the kinds of disruptions we're talking about now, especially in this arena of digital transformation, the disruption will make you irrelevant. It's not irrelevant. You will be irrelevant if you don't react to it. Another option, another approach to disruption would be to isolate the disruptor, put it in a box somehow, regulate it, confine it, and therefore make it irrelevant, or at least let it waste away. once again, that's not something we can do where digital transformation is concerned. It's now too ubiquitous. It's everywhere in all aspects of society and all aspects of industry. As some of the things we've seen, it's in every industry now. So we can't isolate it. It's too late for that. A third is you can try to eliminate or ban the disruption. And we are seeing that happening in a few places of people trying to regulate the innovation, regulate the use. We're seeing that in particular around some of the social media elements, trying to provide some regulations there, trying to control it. We do have the whole issue of what is considered ethical use of digital transformation. But once again, assuming we're not going to be able to totally ban it, we may be able to regulate it some, but we can't eliminate it or ban it. We're left with the final two options. Well, the fourth option listed there is to challenge the disruption and compete against it. And that's to compete with your old way of working, with your current way of working, the Industry 2.0 or 3.0, wherever you are right now, and compete against Industry 4.0 and try to be faster, quicker, cheaper, smarter, better at doing what you're doing so that the disruptor remains out there as, well, they're too expensive. Yeah, it's kind of cool technology. It's interesting, but it's too expensive. It's too unreliable. It never gets down one of those curves that Tom had shared with us about driving costs down because we are so efficient, no one wants to switch. I don't think that's going to be effective either, just because there's so many places where we're seeing the technology proliferate that we're not going to be able to effectively compete against it, which leaves then the last one, embrace the disruption and become one of the disruptors. And that's the strategy that I am recommending. It's a strategy that we've essentially been talking about, is how do we embrace the disruption? How do we embrace the digital transformation and now use it to become a disruptor in our industry, to become a leader in the industry, a leader in whatever area that we have responsibilities for, that we are trying to dominate. Now, I also, because this particular talk is pulling together all the pieces into a strategic thinking element, I just want to mention what I mean by strategic thinking and how that works. Is that strategy occurs at multiple levels. There's the corporate level strategy of this is what our organization wants to be. This is our vision for the future. Then that often has a business unit strategy that's supporting the corporate strategy, but it's much more about what are we trying to do in this market? What are we trying to do with these product lines? How are we trying to compete in this area? And that business strategy often gets broken down into functional strategies. What's our manufacturing strategy? What's our marketing strategy? What's our IT strategy? In many of the organizations that I've seen and worked with over the last few years, digital transformation is still being thought of as an IT strategy. And it's being held there in the IT world. And what I'm suggesting to you today is digital transformation says it can't stay an IT strategy. It has to move into business and ultimately corporate strategy. And that's what I want to talk about, is how do you move from the IT technology piece into a corporate strategy, into a corporate approach for how you want to move your organization forward. And of course, any strategy, you're going to have the vision, objectives. That's classic that we see in strategy formulation. But what it really comes down to is strategy performance, strategy execution is the project prioritization and resource allocation. We can have a beautiful vision. We can have all kinds of objectives. But if we don't apply the resources to it, if we don't lay out the projects to implement it, we will never achieve that strategy. So strategy really plays out in the resource allocation, prioritization of projects. We're going to talk about some of the types of projects that you might want to do based upon the kind of strategy you'd like to go forward with. But in order for that strategy to really be effective, we want to leverage strategy enablers. Now, what does a strategy enabler mean? That's something in your organization, in your industry, in the environment you work in, that can allow you to accelerate your strategy and magnify the impact of the strategic changes, the strategic moves you're making. Now, there, again, have been a variety of things over the centuries that have helped that happen. We saw some tremendous magnification of strategy during the world wars, where new technologies, new ways of communicating, new ways of transportation were happening. So things, there can be global things like a war that can create a strategy enabler. But we want to focus instead on the strategy enabler of digitalization. And by using it as a strategy enabler, we're going to move digitalization from digitalizing our processes on into actually digital transformation of our enterprise, of the organization we're with. So let's talk about this some. Digitalization leads to digital transformation of the products and services and procedures, everything we're talking about. And Roberto just mentioned that a few minutes ago. He talked about how we can start at that digitization, just turning mechanical things into bytes. Digitalization, which now starts us to improving our processes and re-engineering the way we do work, to finally digital transformation, which means we're approaching our organization approaches the market, approaches the world in a different manner. So digitalization goes far beyond just the automation of our processes and activities. It creates new data streams, new processes. It creates a new world. And so that's where the discussion that Dr. Ron had about the metaverse is so interesting, because it creates a whole new world of how we may operate, new capabilities, new insights. Not only does it create that new data streams, it does take our existing data streams and analyzes and distributes that data, works with it differently. And that's classic digital twin work, which is we're taking existing and we're now converting that and using that in new ways to create new capabilities and new insights again. The results of this digitalization is the transformation we just talked about. New markets, new businesses, new dimensions of competitive advantage, new ways of connecting with our customers, new ways of connecting our business with the entire market, new markets opening up to us, new levels of performance going far beyond where we'd ever been performing in the past. Again, we see that whether it's because of the power of the computational power that Tom Coughlin talked about in terms of memory, giving us abilities to do things, to analyze things, to see things in ways we never could before. Taking that digital twin that Roberto talked about. And I was, as he was going through the digital twin discussion, I was reminded early in my life, I was a fighter pilot. And we were getting all kinds of signals, data signals into the cockpit to help us be able to augment the way that we could actually move our aircraft through the skies, do the mission we had before us. And it was already, we were trying to let that machine become us. You know, we often talked about it as a case of we were strapping the machine on our back and going up there and just poking holes in the sky. But we were already thinking like the machine, and the machine was augmenting what we were doing. That was very rudimentary digital twin, but with the information going back to the people on the land, on the ground, in addition to what we had there on our heads-up displays and other information systems. Well, I want to talk now about 5 different strategies that you might choose to leverage in your digital transformation. The first strategy I want to mention is an innovation strategy. Now that kind of makes sense if we're talking digital transformation, innovation, those come right together. We bring those together. And the vision here is that you want to be the market leader in some technology and or customer satisfaction with your technology. We're using technology to lead in the market, lead in a way that puts you ahead of others, keeps you on the front edge of the marketplace you're operating in. And your strategic objective there is now to create and apply these new technologies to products, services, and systems in ways that are going to constantly keep you in front of your competition. Well, if we look at some of the kinds of digital technologies that can help us with that, well, we can look at adding totally new data streams with using IoT analytics and getting that information, now having information that we use in different ways. And of course, that also leads us to digital twins, is also part of that new data stream, is bringing in the digital twin information. We can deal with the new connectivity, and that connectivity now gives us access once again to all over the world, to any device, any system all over the world. One of the earlier illustrations that was mentioned was GE's medical imaging systems. And I can recall in the days when I worked at GE, we had the ability to actually read what was going on in medical imaging equipment anywhere that it was installed in the world. And we could look at it back where we were in Wisconsin, and we could understand the health of the machine. We could help read the data. We could help work with it. And that was that connectivity. That was, again, just on a limited basis, but now much broader, much more expansive. We can take that anywhere with the cloud computing, remote access, access to the internet. We are now able to have the connectivity worldwide. New functionality, and we see this right now in things like autonomous vehicles, the automation, the drones, robotics. We're finding just functionality showing up many places. Even the new platforms that are being developed. One of the examples of a company that is using innovation as their strategy is IKEA. And one of the things they've done is they've created these home centers that you can go to, that you can now look at all of your appliances, your furniture, everything in your home. You can automate it and right there online decide what you want, figure out what would work best for you, and then from there turn that into the orders that you want. Again, through the automation, through the platforms that they're working with, and all the interconnectivity, new functionality available to you now. Of course, new customer interfaces. We have lots of different ways for the interface for our customers to now connect with us. They can connect with us 24/7 through apps, through all kinds of automation, and they can do that in a way that they can trust what's happening through blockchain. That's another thing that's really helped to expand some of the customer interfaces, along with the supplier interfaces. And once again, automating our supply chain, being able to connect that has been all of these helping us in this area of innovation strategy. Well, that's one strategic direction you can look, is how do I have the neatest, coolest, best things that no one else can do? Another way that you may want to use as a strategic change to really transform your organization, your industry, is to look at using a sales growth strategy, which is now, I'm not trying so much to lead with technology. What I'm trying to do is lead with my interaction with my customers, be the preferred provider, the preferred supplier for whatever products or services we're providing in the market segments we want to focus on. And that's the vision, and the objectives on that is that we establish and sustain a dominant market share. And the way we do that now is going to be by how we connect with our customers, how we become so interwoven with what our customers are doing that they just naturally turn to us all the time for everything. That grows our sales. That sales growth strategy is a way that we turn to them again and again and again. Some of the digitalization enablers that help us with that would be obviously strengthening your whole customer relationship with the way you integrate. And that involves the personalization of apps, being able to provide virtual or augmented reality. Again, making that letting your customer feel like they're right there with you, doing whatever it is they're trying to do. They can try it. Again, Roberto had an example of that, of being able to try. I think it was with MVIA. He talked about you can try using the equipment until it's done exactly what you want, and then they build it that way. Obviously, there's all kinds of automation and analytics that are helpful in this area. AI and blockchain, again, help with these apps. Another example of a company doing this that has done this very well is Amazon, and the way that they have used this to grow their sales by moving from initially being just selling books to then moving out from books to other products and on into now you can buy clothes and food and any kind of white good products. You can buy cars. You can even buy some real estate on Amazon. They've taken that sales growth package, what they've taken the sales formula that they have, and they've expanded into every market they can imagine. So another way to improve your sales growth strategy, reducing the time to market. Another thing that comes out of the Amazon example is the Amazon Prime, which gets things delivered sometimes same day, often overnight. So you get it right away, very fast, products and services. Again, that's going to require both possibly some redesign of your products and services into a digital or modular design so you can customize, you can then digitize. And of course, digital twin helps with being able to make sure that you've got the right products and services at the right time. Finally, we can, through the digitalization, we can now lower prices for many of our services. And so we see that many of the services that in the past that were performed on site, and I'm thinking now like on-site maintenance, service kinds of contracts, now that can be done remotely, and the pricing has dropped dramatically because that, but with that, the organization is able to grow their reach. They're able to now provide many more products and services because they have that ability to provide that remote service, that remote option, and it's lowering the price that they're providing it. So you might want to be looking at innovation. You might be looking at more the sales growth, that customer connection. Another way that you might be, another strategy you may choose to adopt would be one of a cost saving strategy, where you're trying to really drive down your internal costs. And of course, the vision there is to be the low cost provider of goods and services within your selected markets. And the objective is to eliminate any non-value added costs and any friction within all the business systems and the product service designs. Now, this is a place where Lee had earlier mentioned things like Lean and Six Sigma. Those were looking to eliminate non-value added costs. Those were things that were in that Industry 3.0 trying to eliminate that. But as we move on now to the digitization world, the digitally transformed world, we find that we can have yet another order of magnitude change in our costs. We can, through automation, we can reduce a lot of the labor costs, the automation, robotics, and it's no longer just now confined to factory floor automation. We're seeing robotics in many of the office applications. We're finding actually even with the virtual offices, something that's really come to the forefront because of the recent pandemic is that many people working from home now, working from wherever, all of that allowing the digital service, digital delivery, reducing those labor costs dramatically. We also can see a reduction in material costs, again, through digital modular design, allowing us to determine what's the most efficient use of what material we have. But another interesting thing that's come out of this is through the buying platforms. The whole platform model, the supply chain, where now we've got interconnectivity with multiple suppliers. We're able to share information with much less friction. And a lot of that friction was embedded in our material costs. Much of the material cost was the overhead of purchasing, testing, validating, and getting things in place. Now we can remove much of that through the platform buying. And so these platforms have really changed how that element of the cost has helped reduce that material cost. And we've been able to reduce our own overhead costs, once again, using things like blockchain and automation, the analytics that we have, all of these helping us to reduce our cost structures. An example of a company who's done that well is Tesla. They have really, as they start to design any kind of an industrial office application, they start right up front by asking, how do we digitalize the processes so that we don't even have embedded costs that we have to take out? Let's start with a low cost structure right from the beginning. They've been very effective at doing that. A fourth strategy that you might consider is the sustainability strategy. This has been coming to the forefront over the last few years, again, because of the European taxonomy and the ESG move in the North American world. The vision here is to be a leader in sustainable operations, both from an environmental and a societal standpoint, and from a strategic, strategy upgrade. What we're looking at is to change products and processes to become that industry leader, and being able to make sure that we understand what are the metrics and standards that are going to be applicable to us. And those right now, somewhat in flux still, depending upon where you are in the world, those standards around metrics and standards that you're expected to meet in this area will be different. And so from an objective standpoint, you want to make sure you know where you're operating in the world so that you can be setting appropriate objectives for the work you're doing. But some of the digitalization enablers here is able to us to evaluate and upgrade our business systems. And really looking at everything from a system standpoint. And in that systems, group, we can now look upstream, downstream, determine what our true environmental footprint is, and avoid some of the local optimization, the bounded rationality that we find when people are just looking within only their four walls and not realizing the tremendous environmental or societal impact they may be creating beyond that. Well, again, digitalization helps us look beyond that. We take that systems view. We've got through digital twins, through AI, we can begin to look at different ways of handling that and understanding how the business systems are impacting the environmental and societal world. We can also look at reducing waste streams. Once again, through digital modular design, I can reduce the waste that I'm creating. It allows me to do a lot more reuse, and that's, again, a major element of the taxonomy in Europe right now is the reuse piece. And so we can reuse, recycle. And of course, virtual office has helped us also here to reduce our waste streams because we don't have nearly as many people commuting back and forth, creating the waste associated with the commutes, associated with just a lot of the industrial nature of society. And another one here is in the area of safeguarding our customers and our employee information. That becomes an important element here of the sustainability is the whole cybersecurity element. That is something that is important in this area as part of the social sustainability, is we need to make sure that we have protected that. And again, digital tools help us with this, help us to be able to, through blockchain, we can help us control what's happening in any transactions. Through cybersecurity, we can be protecting our information, our databases. And of course, again, platforms here can help us leverage the technologies that are out there, the digitalization that's out there to improve the safety and security of our workforce and of our information, both customer information and employee information. Well, the fifth strategy I want to mention is really what I call it the expansion strategy. It's not so much that you're trying to leverage that new innovation or make that much better customer connection for sales growth, or even focusing in on cost containment or sustainability. Rather, what you're trying to do is say, I've been very good locally. I now want to be worldwide. I want to do this everywhere. And once again, through digital transformation, the digitalization of our processes, we can soon become a global company, even though we have a very small local presence. We can be engaged in multiple local markets, multiple industrial segments at the same time. And we do that by developing a scalable business platform. It's a platform that we can take lots of places. We can work with it in many different areas that enables profitable, rapid growth and expansion. I'm not tied to huge brick and mortar buildings and facilities. I'm now a virtual operation that is scalable and immediately replicable anywhere in the world. Some of the digitalization enablers here are looking at all of our scalable business processes. And that's when we digitalize our processes, we digitalize them with the view of making sure that they are now scalable. Digital or modular design, automation, the platforms that we're using that have global reach, virtual office applications. So we want to make sure that we're looking at all of those as ways to be able to scale. Another thing that helps us with scaling is looking at products and services that scale, which the digital or modular design in that allows us to be able to quickly transform and to do mass customization, make each product unique to a market, unique to a customer, and yet still have the same core underneath it. Again, virtual and augmented reality can help with that, digital twins, all of those helping us in that area. I think one of the most interesting examples I've seen of that recently is Audi, the automotive manufacturer, with changing to the Audi City approach for how they are selling vehicles, which now means they just have little storefronts, may only have one vehicle there, but you can look at the entire fleet through the digital tools that are available in the showroom that are there. And so they don't need to build these great, big, huge dealerships everywhere. Instead, they can have an Audi dealership in buildings all over the city. It's just like shopping for shoes or going to a restaurant. You could swing by the Audi dealership and look at another Audi and make your decision to buy right then because you've had a chance to interact with their digital platforms and digital systems. Again, transforming what they're trying to achieve. Now, those are a number of different strategies. And I wanted to make that or lay those out in front of you as a way to think about different approaches. Because sometimes we get locked into, well, we are this kind of company, we are this way of competing, and that's what we're going to do. And keep in mind, in digital transformation, there is the word transformation. It's not just the digital technologies, but it's really the change, the transformation. Digital is enabling the strategic transformation that we want to talk about. I love this quote from Einstein. Lee was using some quotes earlier, but this is one of my favorite ones. Without changing our pattern of thought, we'll not be able to solve the problems created by our current pattern of thought. And so that's why we want to step back and with our digital technology, step back and say, wait a minute, how can we envision this whole different world, this whole different way of operating? The metaverse is such a great place to start with that. On that is, how would we operate in a metaverse? And then how can we convert that into the way we're operating in the physical world right now? Incremental digitalization will not get you to digital transformation. I like to use the metaphor of, let's say that you are running a railroad and you decide you're going to embrace digital transformation. And so you start applying digital technologies to your railroad. It makes your railroad faster. It makes it cleaner from a technology standpoint. It's more comfortable for your riders, and you can haul more freight, and you're a more fuel efficient locomotive. But you're still confined to those same rails. You're a railroad. You haven't yet transformed your business because you're still on the rails. What you want to do is step back and transform your business and say, I'm not just a railroad. I am a person and package delivery system. And now we begin to embrace through the platforms, through our partners, or maybe through some of our own systems. We start to embrace trucking and shipping, and we've got hovercraft and helicopters and airplanes, and we're now beyond our rails. We're not confined to the rails. We can reach anybody, anywhere with the passengers and people that we have, because we have broken away from that old pattern of thinking, that old system, and we now are expanding our view of what we're doing, what we're trying to operate, what we're trying to deliver. So as strategy enabled by digital transformation, it really changes our whole business paradigm. New business model based upon the platforms or the ecosystems we're in, new products and services, totally different products and services than we've ever offered before that may even exist out there, so we can create brand new markets. New process optimization, so we can reach much better levels of cost or cycle time delivery, and new management structures helping us to reduce, again, our cost or overhead, but also making better decisions, faster decisions, decisions that really empower our people and deliver value to our customers. So what we're leading to out here is this idea of a strategy roadmap. And so as you're laying out your strategic roadmap using the digital transformation elements, often a corporate strategy becomes disconnected from operations because while we have great aspirational goals, the culture of the organization, the systems don't change unless we make them change. So that's what I'm saying. The strategy has to have the projects and the resources to actually create the changes. And so those corporate strategies that get put on the shelf and dusted off every year, looked at, and then put back on the shelf again, they never really see the implementation because we don't create the projects, create and assign the resources to do the change. Well, our strategy roadmap helps us to communicate what are the projects we're going to do, commit the resources, and we like using the idea of the roadmap because that old saying, a picture's worth 1,000 words. It really helps to communicate to people what we're doing, when we're doing it, how we're doing it, how we're going to change, clarifying who's involved, clarifying the roles and responsibility, and really prioritizing the work. It's a dynamic document. You'll see as I show you on the next slide, it has flexibility and accountability in it that allows us to shift and change things around, but yet keep moving the organization forward. And this roadmap format that I've used with many organizations is we lay out what are we going to do in the next 30 days, 90 days, 6 months, 12 months. So we lay that out. And it used to be, incidentally, we just said 90 days, 6 months, 12 months, but digital transformation moves so fast that I'm now talking 30 days, 90 days, 6 months, 12 months, because the world is changing so fast around us. And then what we look at is each of those areas that are affected. So we've got the customer relationship, the products and services, our operations, the platforms and ecosystems, the way we're going to be connecting with others, both customers and suppliers, resources and partners. Who do we need to hire? What kind of training do they need? How do we get our workforce up to speed? Technologies that we need to bring on, when do we need to bring them on? Where do we need to use them? Where are we going to apply them? And then finally, any other organizational changes. And often those have to happen also. And we look at all of those and make sure that they stay in sync and see all of those happening together. That's a template I would encourage you to use as you put together your strategy, wrapping up all of these different things we've talked about today so far. If you have any questions, I'd be happy to answer them. You do see my contact information there. I do have one other URL there at the bottom. The Institute for Digital Transformation is in the process of releasing a digital transformation manifesto. Principles that we think are important for any organization doing that. And if you'd like to sign on to that manifesto, you can follow that link and go there. And if you agree with the 8 principles we've laid out, you can sign on with that. Okay, Lee or Dr. Yuan, I'm not sure who takes it next, but I think we go to the the roundtable.
Thank you, Ray. Thank you so much. In the interest of time, let's go to our next item on the agenda. It will be the panel discussion moderated by Alex Lee. So let me briefly introduce Alex. So Alex is emerging IT and digital technology innovation and sustainable business strategy expert with 30 years experience in the high-tech industry. He is a New York State attorney, a founder of the ESG DX Forum, ESG plus digital transformation, and also a founder of the Enterprise Industrial Metaverse Forum for digital twins and AI and blockchain, IoT and XR convergence. Yeah, Alex, the floor is yours.
Thank you. Okay, so this is the final session of today's kickoff meeting. So it's excited. We are going to talk about the metaverse and then in relation to the digital transformation. So in logistics, that all the speakers of today will be a panel, and then so I'm going to have like 15 minutes of the introduction and the set the stage of today's panel discussion. And then each panel will discuss about their view or insight about the metaverse in general, and then whether they can be the super X-ray of the digital transformation. So they will be each talk for 5 minutes. So we will fit into 30 minutes in a time limit. Okay, so without any delay, I will start in generally what the status of the now and the future, and whether they can be related to acceleration of the digital transformation. So you can see that Gartner predict 25% of people in the world will spend at least 1 hour per day in the metaverse by year 2026. So it's only for 4 years left. Yeah? So it's huge people will be into the metaverse. So how can we build up? And then for the scientific Americans, say the special computing. The special computing is one way to actually you digitalize your world, people, object, environment, everything, and then their activities put into your digital space. And then so this is the fundamental blocks, actually the digitalization of your whole space, actual space to the metaverse space. So will be the next big thing. And then also CBS News talk about like digital twins. So companies are now building the race to build digital twins in the metaverse. So we already talk about what the digital twins. And then Bloomberg talk about a huge potential, like a metaverse, maybe the 800 billion market next tech platforms. So whether it's like integrate with the XR devices, or is it like a computing cloud, or whether it's like AI, IoT, blockchain, what all the like digital IT and telecom, yeah, will be built up for the supporting this metaverse. Is a huge potential in the market. And finally, in general, in the economics of this metaverse will generate new economic system as large as 13 trillion by year 2030. So it's less than 10 years. So this is the one we have now and in the future. Okay, so I'll try to help you to understand what really means metaverse and what the current state and the future. So I will give you some snapshot, but I'm not going to tell you everything here, but I summarize everything in one page. So you may be difficult to follow everything, but I'm going to share later. So you can see detail, but I would like to pinpoint how actually can we develop metaverse. So actually the definition of metaverse is a physical and virtual converged world. So how we can converge two worlds? So it's the easiest way is you purely build a virtual world. We know about it, right? Everything is virtual. And then we are living in the physical world. And then how it happened, they merge. First, the real world, like an object, you and me, and buildings and land, everything will be joined to the virtual world as their digital representation. So for the people, they will call avatar, right? So, and then you see that a lot of the virtual things will be mixed with the real thing, the virtual space. And then also you already know about the augmented reality, means that your real space will be joined by virtual space, so augmented. So we call two space mingle in the first step is augmentation by each space. So virtual, augmented virtually means that there is a virtual space is augmented by the real space. And then augmented reality means the real space augmented by the virtual space. And then talk about the digital twin. The digital twins means that you will set up the middle world, exactly the two worlds that are linked together, and then they're mirroring. So you can think of a physical twin, digital twin. They connected by real-time data flow, for example, IoT data flows, and then they're mirroring. So they are mixed together. And then you know about a mixed reality. So all the realities will be mixed together and then in between. And then finally, you will have for example, Matrix in the movie. You don't know where you stay, whether it's virtual or not, right? So I'm not sure we can go the stage, but this is a paradigm shift. And then also you all talk about, or the speaker talk about what is the fundamental building for the technology innovation to support this kind of vision. And then you talk about for example, XR devices and human computer interface, like brain interface, and also a digital sense, right? The very sensing technology is very important. And also AI, we already talk about a lot of the AI technology will be needed. And also 5G, telecom, IoT, and the spatial computing, and also most importantly, digital twins. And then also we are a fundamental block blockchain and Web3, a decentralized technology. And then also we need how we can build up a 3D technology, how you map a digital space and then a physical space at the same time. So this is the fundamental one. And then it will be adopted in industry first, and it will be deployed in the mass consumer market. So what we bring will have a new experience in this metaverse space. So this is what I summarize everything up to now, that every industry in particular, they're trying to build up their own metaverse space. So for example, in the fashion, like a famous brand like Nike or the Gucci, they have their own brand in the metaverse. So they have a metaverse shop or shopping mall, or they're for example showroom in the automotive industry, and then also retail, the virtual shopping mall everywhere there. And then also you have Disney metaverse theme park, and then also you can think of even bank, and then also you have in the sports and the travel and the real estate restaurant and education and healthcare, even the manufacturing, all the factories or your business will be metaverse. So this is a trend that we have. So how can we build up digital transformation? So digitalization of your real space and add up to your virtual space, also transforming your life, your business, and then your everything, like for example, your experience is completely different. So what it means is metaverse transformation means that there is a super accelerator of the digital transformation. This is my view. Okay, so having said that, so we have literally have a distinguished panel. So they have a, if they include their add up their experience, expertise, yeah, is at least as far as I know, they have at least 30 years experience in each industry, and then a lot of the different positions. So even they experience a lot of the emerging technology cycles. So there is good position to share their insight, their experience about the metaverse. Okay, so starting from Lee, we are going to discuss about Lee, how about you start your insight about the metaverse in general, and whether they can be like accelerator of the digital transformation?
Well, initially you think metaverse is just another way of displaying information, and as I talked earlier, a lot of things have changed since the 70s, where we had IBM kind of monitors and digital VT100s, and excuse me, we were just lucky to get alphanumeric information up on the screen. Fast forward today, you still got the information, but we've built a world of relationships around that information that you can interact with. Now, I think that's kind of cool if you think, but since we're focused on beaming the information almost directly into people's eyeballs, metaverse again sounds cool, but I don't know how much the average human being can take the helmet. 10 minutes, 2 hours, take it off by lunchtime. We still got some things to work through to make sure that the helmet is practical. But in the meantime, Roberto mentioned that standards and concepts were being designed. I hope it all comes together such that metaverse becomes a tool that we can actually use. So I'm on the bench watching right now, you could say. What will come next that will make the tool worth all the hype.
Thank you, Ray. How about you?
Thank you. I think the term metaverse and digital transformation in some cases are interchangeable. Some people commented that metaverse is a more sexy term compared with digital transformation. So it's basically sort of like that metaverse is about everything, every existing and emerging technology. But such kind of, I would say, such kind of view has both pros and cons. I would say that according to my observation, there are probably 3 or 4 groups of people who are talking about metaverse, but they are actually meaning different things based on different areas they came from. One is XR. So many people are used to be working, have been working in the XR, extended reality area. So when they are talking about the metaverse, they would mainly mean like virtual worlds, how to create virtual experiences. So I think I'm part of that group, sort of. And companies like Meta and Microsoft and NVIDIA, I believe, are also could be classified in that group. And another one is very close to the first group, which is digital twin. I think this group could be sort of considered as the same as the first group. except for the focus. So the XR group is more consumer oriented, but the digital twin is for now is more enterprise oriented. Third group was like I would say many people, especially those from strong artificial intelligence background, they keep talking about digital being or virtual humans. So they wanted to drive digital beings or digital humans with artificial intelligence. Of course, such kind of technology has application scenarios in both consumer and business markets. So I heard many people are addressing the metaverse from that angle. And the fourth group is from the crypto, decentralized, and NFT area. So those people that talk about the metaverse, they are mainly focusing on creating some digital arts or digital assets in the form of NFT and trying to make money from that. I'm not saying that is not right, but I think that is sort of not the key or the core of the metaverse, in my humble opinion. So I think first of all, the industry would benefit from making a consensus on having a consensus on the definition, even a broader definition of the metaverse, and probably we could come up with some terminology standards specifying like different types of metaverse, different levels of metaverse, things like that. So in order to avoid the situation that the metaverse is just an alternative name of the digital transformation, in my humble opinion, as I mentioned in my presentation, I would say that the metaverse should be a vision, should be a long-term goal, and should be the advanced stage of digital transformation. That's my 2 cents.
Thank you. How about Tom?
Been a little while. Why don't you remind me of the question again?
Yeah, actually, because we discussed about a lot of the aspect of the digital transformation and the metaverse. So I'd like to hear from you that your insight about in general about the metaverse and current and the future, and
Sure.
whether they can be like accelerator of the digital transformation.
Sure. First of all, let me just do something quick here. I was introduced as a president-elect candidate, but I'm also supposed to make a statement that there are 4 candidates for this year's balloting running for IEEE president-elect. The other 3 are Kazuhiro Kasuge, Kathleen Kramer, and Mikey Lucan. And you can learn more about the candidates on the president-elect candidates webpage, which is IEEE.org/PE23. If you do have questions to me about my candidacy, I'm happy to talk with you offline. So I needed to do that because you're supposed to do that for an IEEE event. So my apologies. I think that digital transformation is referring to a broad set of activities that are dealing with creating more information in digital format, and therefore making it amenable to all the technologies we develop for processing digital data. And I think one of the applications is to create more immersive experiences and new ways for us to interact with each other, which I think has been stimulated enormously by the pandemic situation, with a lot more people confined to where they are. We've been using Zoom and other types of communication. It'd be nice if we can go beyond the little boxes that we're all in right now, to something where I feel more like I'm looking at you, for instance, Alex, face to face, in a real environment. I think these are all parts of, I see this as almost sort of a part of a bigger thing of who we are as human beings, and that we're, our natures are such that we're constantly endeavoring to explore new things, to understand things, and understand ourselves in ways we've never done before. And part of that is, we learn about ourselves through interaction with others. and finding new ways and new methods that are enabled by technology to do that are part of what it's going to be a human in the future. And so I think learning how to do more immersive interactions with data, with other people, with the world around us will lead to new understandings, new concepts of who we are, where we are in the universe, and also allow us to do new things and to expand to meet the needs of the future. One of the things, besides just creating things that are more internal, like being able to interact with each other, technology is also going to soon enable us to become an interplanetary civilization. Not just on the Earth, but on Mars and orbit and various other places. And all these technologies will be key parts of making that happen. So digital transformation is part of a bigger effort, I think, that I think is fundamental to a very important and positive part of being a human being. And that is knowing ourselves, knowing the world better. These are tools that will help us to make that happen. So I hope that gives, maybe a little different insight from what some of the other folks are saying. Thank you, Alex.
Thanks, Tom. How about Robert?
Okay, well, to me, metaverse and digital transformation are quite different things. So I do not buy into the fact that they represent the same thing and they are usually interchangeable. There might be some people doing that, but I think it's wrong. The metaverse is a static thing, is a space, okay? Digital transformation is about an action. You are transforming something, okay? And you're executing it. Now, the result of a digital transformation might well be a metaverse. That's fine. But you can also create a metaverse without a digital transformation. Actually, many startups are starting by creating the metaverse, and they do not need any digital transformation at all. Now, for that part of companies, and are many, of course, that are embarking in digital transformation, therefore they are transforming part of their digital assets and the processes in the physical space into something that goes in the cyberspace, they are creating actually a metaverse. But I guess that most of these companies, by far, will need to keep also the physical space. So I see only a very minor, very, very little portion of these companies that will completely go into the metaverse and forget the physical space. So the point is that how can we connect for this company the metaverse that they have created through a digital transformation with their physical space? And the other thing, an interesting question, is whether in this process of digital transformation that result in a metaverse, are they able or will they be able to move also the marketplace into the metaverse? Now, this is an interesting point because it means that the customers, their customers, will actually roam the metaverse to access their products, to use their products, and so on. But I see this again as something that will happen also in a minority of cases. In order to have really a huge proportion of the marketplace and the customers moving to the metaverse, I think that we need some ways, some mediation device that should be much, much better than the goggles that we have today from Oculus Rift or something like that. I attended the presentation of Accenture just 2 weeks ago or something like that. And the presentation was an hour presentation. You find it on YouTube. It was called Meet Me in the Metaverse. Okay, so it was right there. And actually the two presenters at a certain point that were using this Oculus Rift or sort of, and I can tell you that I wouldn't be able to wear those kind of things for more than a few minutes. So I cannot imagine that the broad audience, the marketplace, would actually be willing to have this kind of thing. Personally, I think we are still quite far from having a seamless device that can connect me to the metaverse and to live in the metaverse. It might come. I don't see it coming in this decade personally, but Tom may object to that. He is the one who knows. So I think that we have to keep the two concepts separated. They are connected, but they are separated. Thank you.
Thank you. I'd like to make some comment about your view, because your view is somewhat that I share with you some part now, because yeah, definitely a lot of the company now, what they're doing is completely virtual, not actually not connected to the real space. And then the digital transformation means that through the digital transformation, actually the transformation of the real world. Right? So I like your view. And then actually I try to the same thing to like have a like a common sense with other experts in the metaverse. Maybe not I'm not a mainstream, because because a lot of people are not thinking about my view as connecting your virtual space with the real space and transforming not just your digital space, but your real space will be the complete digital transformation. So I want to share just briefly about my view about how they connect. You mentioned about the like economic system. So okay, I want to just show one thing here. So can you see that? So actually what many people are now focused on here, virtual space. So they put everything in here. So here is a digitalization. So everything it will be digitalized and then put in the virtual metaverse space. So a lot of people are doing it. They call like the creative economy or the virtual economy, metaverse. A lot of the people are concentration is a virtual economic system. So everything is happening in the virtual space. But how they actually can be connected to your space through the digital twin. That's what actually I'm thinking about. Digital twin is very important. It will be the connector between the real space and virtual space. So what will happen in your karma? So for example, that everything will be in the virtual space, but this is really happen now. It's a lot of the like auto dealers and now build up their like auto shop. And then you have to build up your adaptability to your like a virtual showroom. And you look at like whether it's a Hyundai or the Toyota or it's Tesla. And then look at it in the 3D space, you can experience whatever you want, like what is your like a favorite car or something like that. And then what happened actually that he selected someone and then agents in here will be happy to buy it. And then he pay by the cryptocurrency in the virtual space. And then they can be a lot of things actually you can do they can also have a financing in the virtual space. But actually how can connect? Actually, there should be some connection between the virtual space and real space. That's why I call digital twin. So for example, that if you have like a car selected and then you want some options, so favor personalized option to you, and then what now trying to do, for example, like the NVIDIA Omnibus platform, they can build up your factory even in the metaverse. So, but they are connected to your real factory here. So they connected. So whatever you have like choose the option will be reflected in the real factory. So they will build up your own car based on your preference, and then they will deliver to your space. So this is the real space what happened. And then what really is something that are not realizing here is actually how you actually realize your cryptocurrency through the currency in the real world. And then now it's only through like they call cryptocurrency exchange. And then but this is one view that even this is with the business or the real life, that in the future that if you have a connection between your virtual space and real space, and then what you have in the virtual space can be reflected to your real space, and then they will be transformed. So this is my view, but I'm not saying that this is generally accepted. This is my view, but I like your view that like they should be something reflected in the real space. Okay.
If I may, Alex, I just want to point out, because this is actually at the core of the digital reality initiative in the IEEE, is the fact that what we're seeing is that the virtual space is becoming part of the real space. And actually there will be no distinction between virtual and physical once they are all real. But in order for that to become true, you'll need this kind of mediation device that is seamless, okay? And we don't have this kind of thing now.
Mm-hmm.
But
you know that you know that because I talk with a lot of the new generation. For example, my daughters, and then they are the like we call M and G generation, and then much younger generation. They like in the Roblox, like it's a game. Yeah, hundreds, thousand, million people are gathered together, and then I try to understand why they are insisting about this virtual space, and then somebody said like, oh, you are old because you too much talk about the why you try to combine everything you talk about digital and try to combine with your real space. Just let virtual space as it is, right? So I just think about, well, I'm old thinking. So I'm not sure, but a lot of people are still just accept it. Right, we are not the same generation, but I found is the younger generation. They just think about is a virtual space is as natural. So I'm not sure whether my view is correct or not, but I like yours use like a view that here is there are many hierarchies and then not consensus about it. So I think that I especially IEEE law will be even in the academics and the industry and then all the vertical industry and then different tiers that we need something that the unified view of the metaverse. It will be the starting point, and then going to like standardization and then looking at the how we can make it sustainable and something like that. That'll be the law of the the IEEE I think about. Okay, so finally that
Well, Alex Ray is raising his hand.
Oh yeah, I think the Ray is your part. So you can, if you have a question, you can have it, and also you can share your insight.
Okay. First, I wanted to echo what Roberto said about putting that thing on your head. I've done that, and 5 minutes of it, and I wanted it off. But as I look at this, it's going to be what's going to drive the metaverse is going to be use the old saying, follow the money. Where is the money going to be to invest in this? On the one hand, we've got the entertainment side, and that's where, as Alex, as you were just saying, your kids in the virtual world they're in. There's that entertainment, that gaming world that's going to be continuing to push things in that direction. But on the corporate side, I think we're going to see the metaverse being pushed in a very different direction for several reasons. You're going to see the social media people investing into a metaverse to create an avatar for communication. And that's just a communication avatar so that I can sit in my living room and talk with you rather than talking with you over a computer screen. You'll see also in the corporate world on the sales side, when they're looking at selling high dollar, very expensive items that people they want to try before you buy. They want to look at it, touch it, feel it, play with it a little bit. Kind of like what Audi's doing with their vehicles. The people there can actually see what it's like to have that vehicle before they purchase the vehicle. So I see that becoming even more of a metaverse, that sales experience. And then the third will be the training experience on the corporate side, as a particular and training jobs that have either require a significant amount of technical skills or there's a lot of safety related issues. And as we see it in a lot of the classic workforce labor is going away because with so much of it is being covered now through automation and robotics, that for now that everyone needs to be more skilled to do their job. The technical worker of tomorrow is going to need additional skills, and the metaverse is where they're going to get a chance to train, to learn, to practice. So I think we're going to see those parts, the sales, the social media avatar, and the training. Those I think are very much in line with what you just described, Alex, as far as connecting the virtual world and physical world. But I think there's still going to be that entertainment side that is the escapism. That the reason we go to the movies to watch Star Wars or Star Trek today, it's so that we can be in something just totally different, escapist, and that will also be a type of metaverse. So I think we're going to see a split in two different kinds of metaverse applications.
Mm-hmm. Yeah, I think that's a very good point. Actually, I have a webinar in 1 hour. Actually, the webinar is about the sustainable metaverse experience designing. And then what you mentioned about actually what kind of the metaverse experience you can have. And then yeah, FKSD is some type of fantasy. It's like a game. Is one. and the other is like immersion, and then you can, another thing is like entertainment, and another thing is maybe the like education. So we can have a different layer of the experience you can have, and then it can also relate to some applications. So yeah, that's a very good point. Okay, Tom, do you have any question or comment?
Yeah, I had some comments.
Mhm.
There's a first of all, there's a lot of what other people said has a lot of value. The use of a lot of the virtual reality stuff right now is again, it's not as comfortable as you'd like it to be. You're wearing oftentimes a big thing on your head, and what you'd like is to have it built into this. So technology is going to be an enabler. Developments in technology, battery technology to fit batteries into something like this that'll last a long time. Lower energy consumption devices that are built into everyday things, like a pair of glasses that's connected, that could last at least a day, of augmented reality work where you get at least possibly, where you can do a full virtual experience. The other thing is that moving from something where it's games and entertainment into something where it's a bigger part of our lives will require a great deal more security and standards to make possible than exist right now, or at least are in widespread use. So I think those are some important elements. One is the development of the technologies to make this so it is more accessible to more people, and not somewhat of a burden the way it is today. And the other thing is to create the means by which people can carry on more of our regular transactions working in a metaverse type environment versus working in the real world. The other thing to realize, of course, is that the metaverse is a model. It's not the real world, and that can be good in the sense of being able to make predictions, but your predictions may or may not be true. So the other thing that you need to have, of course, is the model needs to be updated based upon new things that we find out as it goes along. Digital twins are only as good as the technology and understanding went into making them. They've got to continue to develop and grow as our abilities do. Thanks.
Thank you, Tom. Okay, so it's almost time. So I thank you for your valuable comment and valuable insight about the metaverse and then relate to the digital transformation. Okay, so I think it's your turn at the level of today's kickoff meeting.
Okay, thank you so much, Alex, and thank you so much, everyone. So I hope you have enjoyed the session. I myself have enjoyed that very much. And this entire session is being recorded. So I hope we could post that on YouTube or on the website in a couple of days. And again, also my sincerest thanks to the audience on Zoom, on YouTube, and on Bilibili, the platform, streaming platform in China. So, I think that's I'm happy to join this session, and hope everyone of you have a thank you so much, and we look forward to generate more opportunities on digital transformation and the metaverse, and looking forward to collaborating with you on those opportunities. Thank you again in the near future. Thank you so much.
Thank you.
Thank you.
Yeah.
Thank
Have a nice
you.
day. Take care.
Bye.
Bye-bye.
Take care. Lee, I think you are raising your hand.
Yes. One thing we'd have is a metaverse magazine that this group puts out. Lots of updates every day. If you want to find out what's working and what's not working, read the magazine. Go to my dashboard that I showed and click on IEEE Metaverse.
Yeah, thank you. Thank you. We will be doing some post-event publicity on LinkedIn and other social media channels once the recording of this session is available. So more people could watch this session on demand. So I hope that would generate some impact that we're looking for. And of course, like for the magazine that Lee mentioned, we can include that in our publicity as well. So yeah, okay. Again, thank you so much. Lee, you have any final closing words for this session?
I'm sorry, I should have lowered my hand. Thank you all. It was good.
Thank you. Okay, thank you so much.
Thanks. Bye
It's
now.
time
Bye.
to have my dinner. Okay, thank you.
Enjoy your dinner.
Thank you. Bye-bye.